All right, it's time. I don't even know, is the microphone working? It seems to be. Wow. Excellent. And what a big room. So many people. Glad you all made it to Austin, made it to our little tutorial. And thanks for being interested in Bokeh. It's a little project that we all are working on, and many, many more people. Let's let people sit down. And then we kick off with a quick introduction. We'll help you all get set up and be able to access the tutorials. Might take a few minutes, and then we'll go through all the exciting things you can do with Bokeh over the next few hours. To start, just a few names of who we are. My name is Timo. We all are contributors for Bokeh. Of course, we're just 4 out of many, many people contributing to Bokeh as an open source project. My name is Timo. We have Bryan, Victoria, and Ian. And the 4 of us will be in the room here for the next 4 hours, taking turns speaking, but also answering questions, helping you directly. So always feel free to talk to any of us 4 at any time. I assume that you have a basic idea of what Bokeh is, since you signed up for this tutorial and are here. We will go into the details of what Bokeh is exactly and how it does the things it does in a minute. Just to level set, what Bokeh lets you create interactive JavaScript-powered visualizations for web browsers. And I think the great thing about it is with Python. So you don't really need any JavaScript to build beautiful JavaScript-powered interactive visualizations in the web browser. So in a nutshell, that's what Bokeh is, and that's what we'll be doing the next few hours. Quick look at the agenda, what we're planning to do. So we'll do this little intro, the part we're doing right now. After the intro, we will work on installing and accessing the tutorial notebooks. So we will be using, like most tutorials, Jupyter Notebooks. So we'll walk you all through the installing and setup process so that everybody can have those notebooks running on your computers and follow along with what we're doing. And once that hopefully works for everybody, we'll walk through our tutorial. We have about 14 chapters. We have some more science specific appendices that we added to this tutorial specifically for SciPy, like a little more details about things like LaTeX integration, for example. So we'll walk through all those chapters. We will take breaks along the way. And at the end, we plan to have an open Q&A session where we can talk about more specific questions, use cases, any thoughts you have, including, of course, also how to contribute to Bokeh, how to become part of the community and work with us and all those beautiful many people working on Bokeh to make Bokeh better for your use case and everybody's use. So that's the rough agenda that we have in mind. For questions, we have a lot of people in here. So first, we'll do the setup and getting everybody up and running. For that, if things aren't working for you, just raise your hand and keep it up, hopefully until one of us, 4 of us comes to you, and we'll help you get running. That's during the setup. And then once we start the actual tutorial and we go through the notebooks, feel free to ask questions when they're directly related to what we're seeing in the notebooks. So if things aren't working for you specifically, or you would like us to repeat something, or we just didn't explain things clearly enough, feel free to ask your question at any time, optimally when it's related directly to what the speaker is talking about. Of course, you might also have other questions, related questions, maybe something about a specific use case you have in mind and so on. Optimally, these kinds of questions would be great to save either to address one of us during the breaks, or of course, if they're for more general interest for the entire audience, try to save them for the Q&A section at the end, where we can then discuss topics like that. That's the general plan, and now how to access this tutorial. This is the link to GitHub. You should see it on the screens. We also wrote it on the board, and it's also in the Slack channel. So we do have a Slack channel for this tutorial. You should be able to find it. It's a pretty long name in the conference Slack. It starts with tutorial and has Bokeh somewhere in the name. I just looked it up, but already forgot. But you can you can try to find it. Sign up. Also sign up for that Slack channel. We'll also be monitoring that in case you have questions throughout the tutorial. So right now in the Slack channel, you should find this link and be able to access the tutorial here. I'll one time read the whole title for the Slack channel, which is Tutorial Interactive Data Visualization with Bokeh. Look at that, exact name of this tutorial. So first step would be for everybody to find a way to access this GitHub tutorial and just see if you can find it. And then we go from there. And then it gets a little more complicated from there. But is everybody generally able, like is Wi-Fi working for you? And can you see that GitHub repo? Anybody has difficulties not being able to access the internet at all, not being able to access that tutorial? Seems like it's working. Very good. So to get the tutorial running on your machines, there's basically 3 different ways to do this. The first one is using the Quantsite infrastructure. Nebari, like several other tutorials, is definitely the way we would recommend you go. And I'll go through the details of how that works here in a second. If for some reason you don't want to use that or can't use that, you can also run the tutorials on Binder, mybinder.org. As most of you might know, they currently have some restraints with capacity. So definitely alternative A would be preferred. And of course, you can also always just clone the repo and run it locally. But of course, then it's a little more difficult for us to make sure you can actually run it, because then it depends on your local system. So we absolutely recommend using alternative A, using the scipy.quantsite.dev system. To do so, we have a little instruction list for that in our repo, and I think that's also linked in the Slack channel. So, no, we don't have GitHub here open anymore currently, but I'll basically try to do that. So some of you might have done that with tutorials earlier today. Yes, so for Nebari, for those of you who haven't used it before yet, the instructions, and I'll go through this on the screen here for everybody to see in a second, you will need an account set up in a Google form, which you can really use arbitrary username or password. It does not require an email address or any personal information, but you do need some combination of username and password.
It's there, isn't it, on top there? Yep.
Yeah. So this is our tutorial repo. Here's the section set up with Nebari for SciPy 2023. And then there's this link, follow this participant's guide, that has all the information of how to set this up. So this is the Google document that you should see with instructions for how to set up your access to Nebari. First, if you haven't done so yet, is the registration. That is this account setup that I just mentioned. There we go. So using this Google form, looks like this. There. And yeah, really the only thing that you need is username. Again, can be any string, basically, any combination that you would like. Same thing for password. And why does it come up with 3D visualization? Oh, right. No. So in this case, because we're not the PyVista 3D visualization tutorial, you would click no on this question. And then coupon. This is SciPy 2023. That is the one information you'll need that I haven't given you yet to complete the sign up. So I'll give everybody a few minutes to go through this Google form. Again, what you need is a username and a password. You'll want to say no to this question about 3D visualization with PyVista, and then enter the coupon SciPy 2023. So I hope signing up and creating username password worked for most people. I'll just keep walking through the steps here, but please raise your hand if you get if you fall off the wagon someplace along the road here. Next. So hoping that you've all been able to fill out that Google form, the next step is to go to SciPy quant-site dev. In this case, I'm already logged in, but you will see, like in this screenshot, a little window asking you to sign in with Keycloak. So the next step is to click this orange button, sign in with Keycloak, and then enter this username password combination that you just created with that Google form. So the sign in window will look something like this, where your username and password that you just created with that Google form.
So will we be able to save our notebooks from there?
I mean, if you want the whole repo, you can just clone it and have it on your local machine at any time. And I think it will store your progress, yeah. But I don't know how much longer after this tutorial they will support this infrastructure.
You can download it though, right?
Yeah. Yeah, you can. The question was, does Nebari store your progress or the notebooks themselves? I'm not entirely sure how long after this tutorial they will support this infrastructure. As far as I know, those logins and this infrastructure is specifically for this conference and for this tutorial. So probably for today or maybe a few more days, you might be able to access the tutorial again with this username and password and come back to it. But I would not rely on that. If you want a local copy of the tutorial, you can always access it at the GitHub repo URL. You can always clone that repo to your local machine for a copy, of course. So the purpose why we're using Nebari here is just to have a reliable infrastructure, basically virtual machines to actually run all the code in those notebooks in a standardized environment for everybody. So hoping you've all been able to sign in to your newly created accounts. Then it will ask you to start the server, and at this point it might ask you what kind of instance you want to run. We've done some testing, and the small instance seems absolutely sufficient. So if Nebari asks you what kind of instance to start, our recommendation is the small instance, and then click Start. So this is the question where it asks about server options. Again, the small instance would be the recommendation, and then you should see a Jupyter Lab window with a lot of environments to choose from, because this is the same for all the tutorials happening at SciPy. Once you see this, the next step would be to clone our repo into this Nebari instance. So again, I'll give everybody a little bit of time to basically make it to this screen where you can see all those environments that are available in Nebari for SciPy. And now hoping that most of you have found their way into SciPy and you see this list of environments in this window. Next step is to clone the tutorial notebooks. A very important step is that was a bit of a holdup for myself even. You have to make sure you're in the root directory here. So in this file browser, Make sure you're in the root directory and not in some other directory, especially if you have done other tutorials earlier today. You might be in a different or in that tutorials directory. Make sure you go to the root directory in this file explorer here. And then we'd go to the Git extension. So this is the actual Nebari interface that I now have on the screen. Make sure you are in the root folder here, and then you'll find the Git tools on the left, this little Git symbol, clone a repository, and in here goes the tutorial repository URL. Again, that's the URL that is in the Slack channel, also up here on the whiteboard, github.com/bokeh/tutorial. That would go in here, and if you click clone and are in the right root folder, hopefully it'll clone that repo, and you should have a tutorial folder right here in your file browser. And then inside this tutorial folder in the file browser, this then obviously is the entire repository. In the repo, there's a folder called Notebooks. And in that folder, we would start with 01 Introduction IPYNB. So I'll open this here, and this is what you should see. So once you're able to see this screen like it is now on the big screens up here, we would consider your setup complete. So I'll now give everybody a few minutes to make it to this screen, and please let us know if you hit any roadblocks on your way to this screen. Yeah, all right. Okay, I think most people have things running. Thank you for your patience while we get everybody set up and figured out. Please let us know if you have any issues accessing this notebook, but for now I'll assume everybody has access to those notebooks and can run them. So we'll get started. We'll start with a bit of an overview, first of the tutorial itself and then of Bokeh and some basic concepts. So what is Bokeh? An open source library for creating interactive visualizations for modern web browsers, like I already pointed out. So you can use Bokeh to use Python to build data visualizations that then are executed by JavaScript in the browser without having to actually write any JavaScript yourself. You can add your own JavaScript, of course, but it works pretty well without even writing any JavaScript at all. With Bokeh, you can create standalone HTML objects, so you can embed that in websites or use it as its own websites. Bokeh also can be run as a server. And Bokeh also, that is the third way basically to use Bokeh, works directly in Jupyter Notebooks. So that's what we'll be doing today mostly, is seeing Bokeh in Jupyter Notebooks. But of course, Bokeh is not limited to Jupyter Notebooks at all. You can create standalone HTML elements, or you can even use it as a server. And we'll also look into those two other ways to use Bokeh also in the course of this tutorial. But again, the main focus is running it in the notebook, as we are doing now. And in order to basically put Bokeh in notebook mode and actually see any output in a notebook cell, we first need the output notebook method that will import from Bokeh. So this is already all in the cell. All I'd ask you to do now is basically run this very first cell and make sure that your Nebari setup actually, or whatever setup you have, actually successfully loads Bokeh JS 3.2. So if anybody not able to run this first cell or see something that is different than Bokeh JS 3.2 successfully loaded, please raise your hand, and then we'll need to look into that. But assuming that this is working for everybody, let's take a very quick look at what a small example of Bokeh. Don't worry, you don't have to understand any of the code that is happening here. This is just to say, with a few lines of code, and most of it is actually adding some random data, we can create an interactive visualization right here with some mouse over effects. And we'll look into what you can do with Bokeh and how you can build those interactive visualizations in this tutorial. So for the course of this tutorial, we don't just want to create random visualizations of apples and bananas like we did up there, or any other random data. We'll actually try to build a comprehensive dashboard with many elements combined together. So if you run this cell, and it might take a while to run because there's a lot of data and a lot of stuff happening in the background, you should see this tutorial that we will be building, this dashboard that we will be building in this tutorial appearing here. It is based on the actual raw data. So if you want to look at the data, you can download it right here. It's the raw data that goes into the notebook, and everything that you need to get from basically this raw data that you can download here to this dashboard is what we will cover in this tutorial. Take a quick look at this dashboard. I'll make it a little smaller just so we can actually see, and then I'll make it bigger again. We have several elements in here, and we'll obviously dive into those in more detail. So we have interactive elements like here, so UI widgets like a slider here. We'll have various mouse over effects, clickable legends. We'll have tools like zoom tools or scroll tools of all sorts that we'll explore. We'll also look into map plots or other kinds of plots and use more interactive UI elements to just build a dashboard like this. The data we're using for this is air carrier data for the US domestic market, a standard data set with information about flights within the US, origin, destination, what gets transported, how many passengers, how much freight, how much mail, and so on gets transported. And this is for the year 2021. So most of us who remember that year, you'll remember that at the beginning of the year, we were all still locked down and affected by COVID. And then in the course of the year, and we can see this pretty clearly in our passenger line here, the number of people using airplanes again jumped up quite drastically. So I hope all of you are able to see this dashboard on your machines in front of you, and you can click around it, play around with it a little bit. And this is what we're going to be building over the next few hours, all the elements that go into building a dashboard like this with all those interactive elements. Quick table of contents that's always accessible in the notebooks if you want to jump to different chapters, but we'll go through all of those 14 chapters now over the next few hours. And we always have the table of content in all notebooks linked up here, table of contents, if you want to jump around. Or if you're using Nebari Jupyter Lab, you should also always have this table of contents basically on the left here. A quick notes how to use this tutorial. It's obviously a series of Jupyter Notebook. I'm assuming everybody is at least has some basic experience with Jupyter Notebooks, what they are, how they work. We have text cells, we have code cells. Code cells contains code that you can execute and see its results. And we have added this little blue emoji icon, this little arrow icon to indicate cells where you can actually do things, change things, experiment for yourself. So this is the first example we have here. If you execute the cell, you get a little bokeh plot with a title, and just go in and change this title to something else and run it again, and then you should hopefully see this title change up here. So I changed my string, I run it again, and now I see the different title here. So we'll have lots of little exercises like this, where you'll see this little icon. We'll give you a few seconds of time to try it yourself, depending on how much or how complex the thing is that you can do in this cell, and then just run it again and see how your changes affect what the plot looks like. So this is the basic idea of how this tutorial is going to work. And then at the bottom of each chapter, you'll find those arrows to get to the next chapter. So that's how we'll navigate through it. Before we dive in terms of prerequisites, Bokeh obviously is a Python library, so we assume you have some basic knowledge of Python, some basic understanding of how functions work in Python, the most important Python data types, such we'll be talking about strings, integers, floats, lists, dictionaries, and so on. We assume you have a basic understanding of that. Basic data operations like slicing indexing, and so on. We'll be using a few Python classes, so very basic Python knowledge. Since this is a data visualization library, we'll obviously be dealing a lot with data, so it helps to have some basic knowledge of pandas, which we'll be using, specifically pandas data frames, which we will encounter during this tutorial. And of course, also it helps to have some basic knowledge of how Jupyter Notebooks work, but I think I just walked through the most important aspects there. Then the topic of JavaScript. Bokeh runs in the browser, so it obviously creates JavaScript. So as I said earlier, it's absolutely not required to know any JavaScript to use Bokeh, but it certainly helps to know some JavaScript, but again, that is not required. But we will have a few elements throughout this tutorial where there will be custom JavaScript code, but only to the most minimal extent possible. Also, this tutorial is obviously focused on Bokeh, but again, lots of data wrangling happens in the background. So there are actually some scripts and modules in the repository that takes care of the data wrangling. If you're interested in pandas, you'll find some stuff in there, but we're not really focusing on the pandas part of how to prepare all that data from the raw zip file that you can download into what we need for Bokeh. We have our little script, carriersdata.py, that contains the relevant pandas code. If you're really interested in how it goes from the raw data to the Bokeh, you can find everything in this script, but for now, we'll just use the data frames that this script produces based on the raw data. All right, before we dive in, some more resources that might be helpful throughout the tutorial, but of course, anytime you use Bokeh. And Ian? Okay, well, actually, I'll leave it small for now because I just wanted to show the Bokeh user guide in a different tab. So, oh yeah, that is working beautifully. We have the Bokeh, that didn't open, the Bokeh user guide, which is our documentation that contains written information about all the concepts and everything of Bokeh. We have the reference guide, which basically documents the entire API for Bokeh. That might be helpful as we go, and always very interesting to look at is our gallery if you're looking for some inspiration of what you can do with Bokeh. The tutorial dashboard that I just put up there, of course, is a bit limited in the kinds of visualizations it has. If you want to see how versatile Bokeh really can be, absolutely take a look at the gallery where we have various examples, including, yeah, here, that's a nice one with some LaTeX in there, different colors, different ways of presenting data and having interactive tools and options to use with Bokeh. That is the gallery. All of that you'll find linked in those tutorial notebooks, and also other resources in case you have questions beyond this tutorial today are linked here as well. All right, let's get started. So our first chapter, chapter 2, is, and we can keep this very short because it's already running for most of you, is installing and setting up Bokeh. So if you're not running Bokeh in tutorials or in a notebook like you are right now, you can always install it with pip and conda. You can run it in the classic notebook, like what we're doing right now. And you can also run it in Jupyter Lab, like most of you are currently in Nebari. I'll not go into the details here, but just important to know, of course, Bokeh can be installed as a standard pip or conda package. All right, chapter 3, basic concepts. So as we go through those notebooks, I'd always ask you to execute notebook cells in the order they are in the notebook. If you just jump or leave out cells, you might get some unexpected errors. And at the top, you'll always find this output notebook function. So always run that first to put Bokeh in notebook mode to see Bokeh's output in a notebook. So you'll find that at the top of pretty much any notebook you'll look at with Bokeh. Yeah, is this working? But you should be able to see the exact same content on your screens, hopefully, as well. but I hope, yeah, that's big enough for everybody to see. So this chapter is really about the concepts, so there won't be much for you to click and run in this part yet, but I wanted to first cover a little bit the basics of how Bokeh actually works, which I think will be very valuable to understand once you actually use code and write Bokeh code yourself. So how does Bokeh transition the border between Python and the browser, and how does that work? Well, Bokeh is actually two pieces of software, basically, two libraries. It is the Bokeh Python library, and it is the thing we call Bokeh.js, a JavaScript library that runs in the browser. And the way they communicate, at least in the simplest version that we're using today for this tutorial, is through JSON files. So the Python side of Bokeh basically generates a JSON file that can then be fed into Bokeh.js in the browser and create those visualizations with Bokeh.js in the browser. So that's what happens in the background. But for most cases, and certainly for the purpose of this tutorial, you will hardly ever see this JSON code or any of that JavaScript code that gets generated. Bokeh provides basically two interfaces, two API interfaces that we'll be working with. And Victoria? Oh yeah, sorry.
Does this work in all browsers? Do you have problems with
Most browsers.
Internet Explorer support was dropped in a recent
Yeah.
version. It was kept for quite a long time. But you can find, I think, Bokeh version 2.43 will still work with Internet Explorer. It's a fairly recent version.
Yeah, the support for, I'd say, legacy browsers is limited. I mean, there are some limits to what an open source project can support. But then all the versions should work, and we have quite the extensive test suite actually in our CI/CD to make sure it runs with quite a large set of browsers, at least modern browsers. That's also why we like to say interactive visualization for modern web browsers, for exactly that reason. Yeah, the Bokeh Python API that we'll be dealing with today mostly has two interfaces or two levels of API interface to communicate with Bokeh. The first one is what we call the Bokeh plotting interface, which is a little more high level, more general purpose, and it makes several assumptions in the background. So you don't need many parameters to get a beautiful working visualization pretty quickly, because it has a lot of sensible defaults in the background. That is the plotting interface that we'll be using a lot. And then it has more a low-level interface that we call the models interface that gives you full control over every aspect of the plot, but that also means that you need to define all those aspects manually as you create the plot. So what we will be doing in this tutorial is we'll basically start out with the plotting interface, with the high-level interface. Most of what we will be doing will be using this high-level plotting interface, but there will be many places where we'll find that we want to be a little more specific about things or want them to work a little different than those defaults do. And then we will start using this models interface and use the models, the Python objects more directly. So you'll see plotting and models interface both in this tutorial. Then, just as a high-level overview, some concepts and basically building blocks of Bokeh. What goes into a visualization? What is a Bokeh visualization? What are the elements of it? On the most general level, all Bokeh visualizations are called documents, and this we will have like a Python object called document that we will interact with. So the whole thing, this whole dashboard basically that I showed earlier with those different sliders and plots and lines and dots, that would be a document. And then a document consists of, well, obviously plots. That's the most common thing you'll find. That a plot is this combination of glyphs and axes and legends and annotations and tools. All this combined we call a plot or consider a plot. They contain many elements, including our little toolbar here, for example. So this tutorial notebook at this point includes a little overview of what those tools are. We'll dive into that, of course, in more detail, and especially how you can customize this toolbar. We'll get to that here later. The next major building block that we'll be talking about for Bokeh is glyphs. We'll be referencing that a lot. A glyph is a visual representation of the actual data. So in this example above here, for example, this line representing our data would be a glyph. Obviously, like a tool wouldn't be considered a glyph. So we have many different kinds of glyphs, lots of which we will see in this tutorial, but of course there's lots and lots more that we won't see in the tutorial, but hopefully you can get an idea if you browse through the gallery of the different glyphs that Bokeh supports. And the next building block, the next major element that we'll be using in this tutorial is what we call widgets. Those are those little UI elements that we saw in our dashboard. In the dashboard, we had the slider element. We had those little tabs to click through. There's a whole library of UI elements that you can use directly in Bokeh. The example at this point in the notebook here is a little date range slider, but that's just one of many, many examples of what widgets are. So we have plots, we have glyphs, we have widgets, and then the fourth basic element and concept that I want to introduce are layouts. And layouts is basically combining all those different elements into a document. And those combining different elements happens in layouts. So again, don't worry about understanding all the code that is in the cell, but if you run this, you'll see there's now a combined element or an element that combines 3 plots into one document, one element, and that happens with layouts. So that's just some basic concepts, basic building blocks that you'll find in Bokeh and that we will be exploring in more depth in this tutorial today. I'll click to the next section. And here we are at basic plotting. That's where we will start, and you will start, to actually build a small, simple plot to get us started. So again, we'll start this chapter by running the first cell. Oh, well, actually, that's a different cell. I hadn't mentioned that before. That's where we import the data. So that is this other Python script that has all the fun panda stuff in the background that provides us those different pandas data frames that we'll actually use to visualize in Bokeh. So we like to load this first into our notebook. Second, we run the output notebook function to put Bokeh in notebook mode, and then we can get going. So we are starting with the basic plot. So obviously, we'll start out with the plotting interface. Again, this is this high-level interface that I mentioned earlier, plotting versus models interface, where we first define our basic figure, customize it, and then print it out. How does basically the anatomy of a very basic plot in Bokeh? If we use the plotting interface like we are here, we'll start off with the figure function to create a new plot, basically create a blank canvas for us to create our plot with. So first of all, of course, we'll import figure from Bokeh plotting. And after that, we create a new plot. Plot equals figure. At this point, we can already start adding some parameters. For example, height and width. We'll go into those parameters in more detail again later. For now, let's just make a plot that is 300 by 300 height and width. So now we have our plot, which is a figure. Basically a blank canvas, not much to see yet. Now we'll add a glyph to make that, to actually see something. First of all, of course, we need some data. In this case, just 2 very simple Python lists containing some data. And now we'll add a line glyph to our plot by calling the line function on our plot object. So that's what's happening here. We have 2 dimensions of data, x and y. We have our line method that we call on the plot that we defined earlier, and we give it the x and y data to do something with. So now we have our glyph, and now the only thing that we need to do is output it, show it, for which we have the show function. After we import it, run the cell, and show our plot object that we added this line glyph to. So now we have a plot with a line as our little visualization. So this was step by step of how we built this. Now we have a little example down here, and this is the first time where you'll see those little circle icons where you can actually do things yourself. So if you run this cell, you'll get this visualization that we just built step by step. And now you can actually change elements. So I'd ask you to take 30 seconds, a minute, to play around with those different things. You can just comment or uncomment things here if you want to make it easy. So our figure is the first one where you can add additional uncomment additional parameters, such as adding a title, axis label, and so on. You can just play around with some values, replace some here. Yeah, or add how you call the line function to add the actual line glyph to the whole thing. So I'll do that here as well. Give you a few seconds before we continue. How all those parameters work specifically, what exactly they do, don't worry about that yet. We'll get into the details of how to fine-tune everything sooner. This is more just to show how by uncommenting or adding those parameters, you can change what your plot looks like, just to get a bit of an idea of the three elements that we see in this plot. First, we define the plot itself with the figure function, where we define some basic parameters of the plot itself, like width, height, and so on. We add some data. We add our line glyph, and at the end, we output the whole thing and see our visualization.
Question. Can you get this good plot out of this notebook? Say it somewhere else.
Yes, absolutely. I mean, yes, we are in. The question was, can I get this plot out of the notebook? Yes, Bokeh has various ways how you can output the results. This one is using Bokeh in the notebook, but you can also always use Bokeh as part of an HTML. So there's various ways to export HTML and embed it in whatever HTML context you have. That's the first two. And the third is you can even run Bokeh as a server and like dynamically stream data and so on. So we'll talk about exporting and server also in this tutorial. But for now, to keep it simple, we're just running it simply in the notebook interface. But of course, Bokeh is not limited to the notebook interface. So let's look into the first line chart that we're actually using in our dashboard. We'll be using actual data. So this is now a data frame that we pull from this data class that we imported earlier. This is actual data from the raw data set. I'm printing out the head 5 lines. We see we have months, we have development of passengers, freight, and mail. And for now, we'll just look at the passenger columns and try to create a line chart that lets us see how passengers developed over the 12 months of the year 2021. So we'll do the same thing again we did earlier. We will create our plot by calling the figure. We'll give it a title. And in this case, we'll not just pass in a list directly as a manually written list. We'll actually use data from this data frame. So we'll use the index of the data frame for our x-axis, the month number, 1, 2, 3, 4, 5, and so on. And for the y-axis, we'll use the pandas set of passengers. So we'll use passengers column and the month column just by referencing them here as x and y. And then we'll do the same thing we did above, where we add a line renderer. We'll give it our x and y. We'll add a legend label for the specific line renderer, do some things to make it look pretty, and then we call show to output the whole thing. So if you run this cell, you should see a plot like this. Not much interactivity or fancy things happening yet, but a very basic line chart of this actual data from our data set. Now this second basic plot that I want to talk about and that we have seen in our dashboard are scatter plots. So here we used one line to visualize our data, scatter plots using multiple points, obviously, to visualize data. Again, works pretty similar. The only difference is that instead of a line method, we call a circle method. In this case, we input the data directly here, so we should have 1, 2, 3, 4, 5 little dots on our plot, since now we're calling the circle method. So same thing again as above. We have figure first to set up the figure, create our canvas. We call the circle method to draw our circle glyphs, and then we show the whole thing to show the results. There's many ways to change that as well. So here we have another cell with a circle icon. So here again, I'd ask you to, just for now, uncomment some of those lines, play around a little bit, and see how you can change what glyph exactly we're using in our scatter glyph, in our scatter plot. So just go through those lines, uncomment different lines here, and just see how that changes what the plot looks like. All right, so if you've done this a few times, you should probably now have seen different shapes appear in your notebooks, circles, triangles, squares, all sorts of different scatter markers. And now, of course, next step would be to combine glyphs in a single plot, because usually you'd want to have several of those, so we can just plot them on top of each other by calling different render functions. So in this example here in our cell, again, we have the figure method to configure our blank canvas. We define some data, and then we do add a line renderer here, and then we just call a circle renderer as well. And if we show this plot, we'll see that the same data gets visualized once as a scatter plots with dots and as a line chart with this blue line here. So we can always use multiple visualizations all at once in the same plot. The next, and I believe that is the last basic example, is basically a bar chart, categorical data. The example here, instead of using numbers for our axis, we now have categories. In this case, we're just counting fruits. So let's say we have 5 apples, 3 pears, 4 nectarines, and so on, and want to visualize that as categorical data in a bar chart. It works exactly as before, but instead of calling a line function or a scatter or circle function, in this case, we're using the vbar function to draw vertical bars. In this case, we don't have a y parameter, but a top parameter that defines how tall those bars are supposed to be. So last thing in this chapter, let's put all this together with the actual data from our data set for our dashboard. Again, we're reading the data from our data frame and creating a figure like we did before, and adding a vbar renderer and show the whole thing. Now, if you output that, there's a few details in there that we haven't covered yet, and we'll get to that in the next few chapters. For example, changing the labor orientation to make them appear at a little angle here instead of being all printed on top of each other. But the basic thing are what we have seen before. We create our plot as a canvas, we add a renderer, we show the whole thing, in this case, vertical bars. And yeah, you'll notice the x-axis labor orientation is changed here from the default. And these are the kinds of things that we'll look into with the next chapter. But before we go to the next chapter, where we will start customizing and understanding how do we customize those very basic kinds of visualizations that we have seen, how do we customize them. Before we look into that, we'll take a 10-minute break and continue with the next chapter after the 10-minute break. So that would be at 35. At 2:35, we'll continue with the next chapter.
All right, welcome back from the break, everyone. So my name's Bryan. I'm going to be taking over the second third, I guess, of the tutorial here today. Wanted to just make a quick notice. If anyone came in during the middle there and has any issues with getting started, please do just raise your hands. We've got a couple other folks from the Bokeh team here who are available to help with any kind of technical issues or getting setup issues. So just raise your hand and someone will see you and hopefully come over and help you resolve those. But apart from that, we're ready to go ahead and get started with sort of the second part, and we're going to start with this chapter about styling plots, right? So Timo gave us a great introduction that showed us a lot of sort of basic plots. We use the Bokeh.plotting API to just get sort of out of the box sort of chart that's got pretty reasonable defaults. But as always, we're going to want to be able to configure our plots to look exactly how we want them. And Bokeh has a lot of knobs and dials and configuration settings you can always use to get the exact look that you want. So let's take a look at what some of that looks like. So first obvious choice to look at would be to look at how colors are specified in Bokeh. Bokeh is pretty flexible when it comes to whatever kind of color specifications you want to use. Typically, any place that a color can be used, we can accept things like the named CSS colors, so just green or red or fire brick or whatever. We can also accept hex codes, right? So the standard # with the RGB or RGBA hex codes are fine. A little bit less common, but it does come up sometimes. You can also use tuples. So you can either give a 3 tuple of RGB values or a 4 tuple of RGBA values, where the last one, the alpha value, is between a floating point between 0 and 1. So just to get a very quick look at that, here's a plot. It's again our sort of fruits basket example, where we've got a bunch of fruits and some numbers, and just a simple V-bar plot. And I think I completely forgot to run the top cell. So I didn't run, that's actually a good point. I didn't run the top cell here. I forgot to run output notebook. So what show actually does in that case is to just generate an HTML file. And that's what opened up there. So just maybe also good to know in passing. But anyway, now that I've run output notebook, I can see that it'll show up inline in the notebook here. And so you can see that this V-bar plot has indigo. And I'll give you maybe 30 seconds to play around and sort of maybe comment or uncomment some of these and sort of see what things look like. There we go. We're very grateful that Ian could make it here all the way from London to also deliver, but I'm going to use this keyboard. Okay, so there's, we can see we've changed it to a hex value. We can change it to these RGB values, and all of those hopefully change in a pretty consistent way that we would expect things to change. And in this case, we're passing the color value. We'll see in a bit that there's actually sort of specific values for line color and fill color. Color is actually sort of a catch-all. It'll change all of the color values for a specific glyph, in this case, the V-bar. So color specifically is a more general class of property we call visual properties. And visual properties in Bokeh are sort of split up into 4 different categories. So one would be line properties. So pretty common thing to want to draw lines for visualizations. Lines have a lot of properties. Obviously, they can have a color. They can have an alpha value for transparency, a line width, line dashing. There's actually more than are shown here. There's properties for line joins and properties for other kinds of ways to sort of fine-grain tune lines, but those are the main ones. Text properties as well. Obviously, we want to be able to add labels and other kinds of text to our visualization, so we can control the font size, colors, alphas for fonts as well. Fill properties. Fill properties apply to basically anything that you can fill with a color. So you might imagine in the previous examples, we drew like a scatter plot and we drew like a circle. The circle has both an outline and then that interior region. And so the part in the middle, that interior region, is where a fill color would apply or a fill alpha would apply. So those are available as well. And then finally added somewhat recently, in the last couple of years, I guess, are hatch properties. So in cases where you want to have another different visual indicator for differences besides color, you can use hatching. And so hatching is basically like sort of a stencil or just kind of a pattern. It's useful for monochrome applications where you don't have color, or if you're really being sensitive to color deficiencies and you want to provide a secondary channel for differentiation, hatch patterns can be useful for that. So we're going to have another example here that we can take a minute or 30 seconds to play around with. Let's just go ahead and run it first, and then we can take a look at some of the things that we can tweak. So here we've got our plot that we created, height 300, we give it a title. We get our monthly values data frame, we set up our data. Here we're going to change the title text font size to 1.2 EM. We can also change the title text color. Our line here, we're passing those visual properties. We're passing the line width, the line color, line alpha, line dash, and you can see all of those reflected here in the line that has a different color and dash and alpha. And then finally, the V-bar plot here, we're also passing some different properties as well. The fill color is navy, but in particular, we're passing a hatch pattern. So you can see it's got this kind of funky spiral there. There's a lot of different hatch patterns that are available, and you can see them in the docs. Another one would be like a horizontal line pattern, or I think a dash pattern. There's both names and abbreviations, but I'll give you all 30 seconds or so to sort of play around with that, uncomment or change some of those values to different values and see how the plots react to those changes. Okay. And actually, while folks are playing around with that, just to mention, I like to sort of always call out to the docs where things are relevant. If you go to our user's guide, there is an appearance and there's general visual properties, and pretty much all the things that I've talked about and sort of given a demonstration of in the tutorial, all of those are here. So you can see an example, for instance, of all the available hatch properties and all the text properties, in addition to the ones here, and sort of see more examples of that as well. So that's under the user's guide, appearance, general visual properties. Okay. So we've seen that. So that's one way to sort of style the plots is to pass these parameter values directly to the glyphs, directly to these, the figure call. We can also use the actual objects themselves and set parameters on those. So basically, when you call figure, you get back one of those models, those low-level objects, and so all of those models, like a plot, have all of these different properties, and so we can set those directly on the objects as well. So let's take a look at what that might look like. Here, we create our figure. We can also set plot.width and plot.height, but outline line color. So this is actually a good example to look at. The plot has an outline, and so its line color is going to be the prefix outline, and then line color. And that pattern pretty much goes throughout all of Bokeh. If you have some specific kind of thing that needs a line color, it would be, foo.line or foo-line color. In this case, outline line color, and similarly background fill color, right? So that changes the fill color for the background because there's also the area around the central plot frame, and you can change the fill color for that too. So in cases where there's sort of multiple things, you'll see this additional prefix that describes the thing you want to change. So in this case, we've changed the outline. We've also changed the fill color, and we've also changed XGrid. So the grid line color here, we've changed to sort of to get rid of. In this case, we've gotten rid of the XGrid, which is the grid that confusingly intersects the x-axis. So it's the vertical grid lines are gone now. And I'll give you 30 seconds or so to play around with this one as well. You can again set the width and the thickness of the lines. You can change the colors and sort of see how the plot reacts to your changes. Okay, so there's some example of changing those. So I've changed a variety of values, and you can see the plot now appears quite different according to the customizations that I've made. So again, we can go to the user's guide and see quite a bit more information about that. Okay, so besides the plot object itself, we also might want to style the glyphs. And again, like everything in Bokeh, there's an object that represents this glyph. And so we can directly assign properties to those to configure them however we might need. So in this case, we call plot.circle. And what that returns is this glyph render object. And the glyph render object has a .glyph property. And we can change, for instance, the fill color or the line color on that glyph sub-object, I guess. And the reason it's a sub-object just tangentially is because there are other kinds of glyphs. If you have like a selection tool, you might have a glyph for non-selection appearance and selection appearance or the hover appearance. So all of those kind of things are configurable. Here, though, we're looking at just the basic default glyph, and we can change, for instance, the fill color on the glyph to green and the line color to blue. So we can take a look at that here. And my eyes are pretty bad these days. I can't actually see, so we can take a second and change this as well. Let's change the line color to maybe black and change the fill color to yellow, and we can see that updates to reflect that. And we can see that those two different properties affect what the glyph looks like. Axes, of course, are also an important part of your visualization. You might have specific requirements that you need to use to communicate or convey things, and so we can configure the axes in a variety of ways as well. Let's take a look at this, and this will also be a good exercise for you to play around with. So the first thing to note here is that we have some convenience accessors on plots. So plot.x-axis and plot.y-axis. And just for completeness sake, I'll say that these accessors will actually change the values for every axis. So it's possible to have multiple x-axes or multiple y-axes. Plot.x-axis axis line color here, that's going to change the line color for every x-axis. You can also subscript .x-axis to get to a specific axis if you have multiple axes. In this case, we'll just use plot.x-axis. We'll change the line color to blue. We'll change the tick line color. Those are the little marks that show up across the axes. We can also change the label size and the line color. And so you can see all that here. Maybe we want to change the font size, so much bigger, 1.8, and we can see the font along the x-axis got bigger. We can change the line color to blue, and we can see that the line color there in the bottom also changed as well. So I'll give you 30 seconds or so to play around with this, change some values. If you have any questions, definitely raise your hand. But just a minute to play around with that. There we go. Like I said, it's very configurable. Just to illustrate that, you can even control sort of the amount of distance that ticks extend inside and outside the plot. So the reference guide will have all of the details on all these different properties that these different objects support. Okay. Let's see. So other things we can do. So I talked about x-axis and y-axis and how those let you, sort of configure all the axes. Some other properties that are useful are things like that major label orientation that Timo mentioned earlier. So major labels. So just to give some context here, basically there's two things to think about when you're displaying an axis. There's sort of the ticks. Where do the actual ticks, appear? And so Bokeh has the notion of a ticker that will choose where those should go. And then there's a tick formatter, and that shows how they look. In this case, one of the things we might want to do is change the appearance by orientating those labels. And so we call the labels for the major ticks to be major labels. Anyway, we can change that major label orientation, and that will affect how the labels are presented. And that's useful for cases like this, especially in categorical cases where you might have very long names. And if you don't use this, let's see what it looks like without it. If I just comment this out. There we go. You can see the labels are sort of all on top of each other. It's not really intelligible what's going on, and so that's why it's useful to be able to tweak properties like this. In this case, 0.8 is roughly pi over 4, 45 degrees. Just an FYI, the major label orientation units are in radians. If I had this to do all over again, not sure I would have chosen radians, but that's what we have now. So anyway, that's what that's for. We can also see that we've applied this numeral tick formatter here. And so this is, again, one of those Bokeh models, low-level objects. We want to be a bit specific here. And we've said that we want this format 0, 0. And so that basically says to use this sort of nice comma-separated, for thousands, as we would do here in the US format. But there's a lot of different formats. And again, those are all going to be laid out in the user's guide and the reference guide for all the specifics for that. Okay. Let's see some other examples. Customizing titles. So you can pass a title to figure. That's great. Plots have this title object, and you can change the properties, the visual properties of that title, plot.title object. So in this case, you can change the text itself. But in this example here, you can change, for instance, the location, the text font size. So in this case, let's change it to 15. Let's put it below the plot. Not below. Is it? Not align. Sorry. Location would be below. Right now it's below. We could change the alignment to be center, and now it's centered. So there's all kinds of these properties on that plot.title object. Again, background fill color here, we could change that. We can change the text color as well. So all those visual properties we mentioned before are the same. Yeah, question?
What options are there for the font size if you're specifying their pixels?
Yeah, basically, so most CSS options work, so you can specify that in EM. So we could do something like 1.5. I think EM, and so there's a plot title, and then we could do, 2.5. I don't know off the top of my head exactly, but we try to be pretty flexible in what we can accept. And so generally speaking, a lot of the CSS type font size descriptions should hopefully work. Yeah, good question. Okay, cool. So anyway, that's some examples of that. I want to go ahead and move on through. Legends are another really important aspect to a lot of plots. Obviously, we can show our data. We can have a scatter plot that shows the relationship between X and Y values, or a line plot. But that's not useful. People don't know what they're looking at. So customizing the legends is super important. For simple legends, the simplest thing you can do is when you call the glyph method here, you can simply add a label to it. Legend label equals temperature, one I call circle, and that will add a legend with a row for temperature for this kind of glyph. But there's other things we can tweak. The location, the title on a legend, if we want to have a title on our legend. We can also change the text color. Again, all of these, the border color and the fill color for the legend itself. So let's go ahead and run this example and see what things look like. So in this case, we've specified a line and a circle. And for the line, we've got legend label temperature. And for the circle, we've got legend label objects. And if we take a look at our plot, sure enough, we've got a temperature and an objects visible in our legend, but we've also specified a lot of other options here, right? So we've got a text colors for the legend items. We've got a border color, which is navy, this sort of navy here. A title, we've decided to add a title to our legend, so you can see that here as well, which shows up. So I'll give you all, again, 30 seconds or so just to play around, sort of change some of these settings and see how the plot responds and reacts, and if you have any questions about that. All right.
Moving the legend outside.
Yeah, so it is possible to move the legend outside. I would actually need to go to the docs to do that offhand because I don't remember. That is possible, and that's going to be under, let's see. So the question was how to move the legend outside, and that's going to be under, I think, annotations here, and we go to legends, and I believe there is a manual legends. Well, I'll have to find that. Let's come back to that at the break. That's a really good question. For a long time, in early days of Bokeh, it was not possible, and then we added it, but it's not maybe the most common thing. But we'll see that. We'll come back to that. I'll look it up at the break. Okay, a good question. All right, so finishing up here, we're going to get a little preview of some things we'll also see in the next chapters. Color mappers and palettes. So we'll sort of see the details of this in the next chapter, but obviously one thing we might want to do is to color map our data, right? We might have a bunch of values that represent temperature or pressure or some other measured quantity, and we want to color map those according to some palette. And so we can do that. So we can do from bokeh.palettes import Civitas, and then we can look at what that is. So palettes in Bokeh are just lists of colors, really in any format, but the ones that are built into Bokeh are all these hex codes. We make available some of the common plots that are available, palettes rather, that are available from other tools, just so they're ready and available to use. But we'll use this one in this case. And we're going to use this with the linear CMap. So this will do a linear color mapping from our data values to this color map. There's also like a log color map, log CMap. But let's take a quick look at what that looks like. So here I've imported linear CMap from bokeh.transform, and we'll talk more about that a little bit later. We've generated some data. We've created our figure. We call our call to our scatter circle here. And instead of giving it a specific color, we give it this linear CMap object. And so what are the parameters of this linear CMap? The first here is Y, and this is saying I want to color map the Y field of my data. I want to use the Turbo 256 color map, which was this, I think, perceptually uniform sort of rainbow alternative that people were interested in the last few years that I think Matplotlib added as well. And then we have to give it a bounds within what are the minimum and maximum values to color map. And so it's min Y and max Y. We're just specifying that explicitly. And then we show everything. And so you can see here that this is color mapped according to that Y value. Now, it's really important to note here that the color mapping actually happens in the browser, in JavaScript, right? This isn't happening in Python, so those colors are actually not really available from Python, which is, has benefits and drawbacks. But in this case, the color mapping happens in JavaScript in the browser, sort of dynamically on the fly, which is just good to be aware of. Okay, we also might want a color bar in case we're displaying like an image. Very briefly, we'll just mention that recently there was a nice convenience function added called construct color bar. Typically, we can just call construct color bar on our glyph. So if we've called circle scatter above, we've got the circle scatter glyph renderer. We can call construct color bar on it, and then we can call this add layout function to add our color bar to our plot. In this case, we want to put it on the right. And if we show that, we'll see that now we have this color bar added. And color bars, like everything else, can be configured very extensively where the labels go, where the sort of the axes ticks are located. So all that's configurable as well. And there's an entire section on the in the user's guide about color bars. All right, last section for this chapter is just mentioning, I'll mention this quickly, themes. So it is possible to sort of define a theme for Bokeh documents. Basically, a theme is just presetting properties on any object that you might encounter. There's a couple of built-in themes that are mostly user contributed. I don't know if the names are especially meaningful. Some of them are like dark minimal, light minimal. Night sky is another sort of dark theme. I'll give you all about 30 seconds to play with this. But again, you can comment and uncomment. If I just run it, we can see the night sky theme sort of defaults this to a sort of dark-looking background and like that. We can change this to do, light minimal. Just gives us sort of a minimal look here that has, sort of dispenses with some of the axis. This is maybe more like a Tufte style plot that avoids chart junk or however that's described. But there's lots of different options here. It's also possible to define your own theme. It's basically just a YAML or a JSON block that defines the property values you want to theme and what their values should be. I will mention here, you can see that it's changing the value of the theme on this curdoc. That's really just sort of boilerplate. Wouldn't worry about curdoc too much in this context. But you can import curdoc from bokeh.io, and it basically means current document. And so you're changing the theme of the current document. Anyway, that's an example for all of the styling stuff. Looking around, I don't see any hands raised, so I'm going to go ahead and go to the next section. And this is a really important section, actually. It's about data sources. So let's go ahead and run our 2 cells up here. So yeah, so Bokeh handles data for almost everything in a really consistent way. I mean, there's obviously different kind of glyphs that are more complicated in some ways, but for the most part, Bokeh uses something called a column data source. And a column data source is basically kind of like a pandas data frame, or realistically, it's just a dictionary that maps names to sequences of data. Those sequences could be Python lists, they could be NumPy arrays, they could be pandas series, really whatever you want, but it's just this mapping of names to data, and that is used consistently throughout Bokeh in almost every case. So let's take a look at what some of that looks like, and then we'll see why you might want to care about this or might want to define your own column data source explicitly. All right, so we import column data source from bokeh.model, so this is one of those models objects, sort of foundational building blocks, and then let's just define one here. So in this case, it's got a data parameter that we pass in, and the value of that is just a dictionary. Again, it maps names, in this case X and Y, to columns of data, in this case just regular Python lists of data. So we can take a look at that. And if we look at source.data, it's just our list. It could be a NumPy array or pandas series, as we'll see pretty soon. In fact, we'll see it right here, right? So here we create our get monthly values. We get the passengers sort of pandas data series out. Here we create a NumPy array, just sort of an A range. And here we create a column data source with X and Y values that are this pandas series, and the NumPy array for Y as well. And so we can print those out and see, for instance, that sure enough, the pandas series is here as a pandas series, and the NumPy array is there as a NumPy array. So the CDS basically is not going to change your data. However you pass it in, it's going to be retained in that format. But this is the data that's going to go into the browser that's going to drive typically glyphs, but sometimes other things as well. Important thing to note here is that the columns of a column data source always all have to be the same length. Like this is the same as like a pandas data frame. You can't have one column that's longer than others. This is the same with Bokeh as well. So you can see that if you try to create a column data source here with X and has 1, 2, 3, 4, and Y that has 5 values, if you create it here, we'll get this warning, right? And so this tries to be a detailed warning that's sort of actionable. It's telling you that the current lengths of the columns, the X length is 4, the Y length is 5. They're not the same. So I don't know what to do with that, right? So that's what that warning is trying to tell you. So I'll go ahead and give you just a second to edit this cell and hopefully resolve this error with the column data source. And you could either do that by adding a new X element or subtracting a Y element, whatever is appropriate. But if we do that, in this case, I'll add an X value. Now we have our column data source. Okay. So why do we care about column data source, or as people usually refer to them in like discourse or Stack Overflow questions, CDS? Why would we care about making our own CDS? And the main reason we would care is that you can use a CDS to drive things like hover tooltips or, again, transforms on data in a much more sort of broad way. And ultimately, it's good to know about them because there's always a column data source. Even if you just passed raw data to like the circle function like we've seen already, Bokeh will be creating a column data source for you under the covers. And so it's good to know how they sort of operate regardless of whether you're creating them explicitly yourself. Okay, so let's take a look at using them for a plot. The basic way this works is we create our column data source. So I've got a data dictionary up here with X values, with Y values. Those are the names of our columns. I create a data dictionary that I pass to column data source. And then the way to use it is now when we call our glyph method, we call circle, we pass the CDS as the source parameter. So in this case, source equals source, just because we've called it source up here. But now for X and Y, instead of passing actual data values like lists of data or arrays of data, we pass in the names of the columns. So we want the X values, the X positions to be this X values column, and the Y positions to be the Y values column, taken from this data source that we passed in explicitly. So if we do that, we can see, sure enough, there's that. It's still possible to manipulate other properties. Like if we wanted to make these bigger and we don't want to have an entire column for it, we could do something like size equals 25 and make those bigger. So it's still possible to put in individual parameter values that aren't derived from the column data source. You can sort of mix and match these single values together with the column source values. But anyway, that's sort of the basic usage. We understand it's probably pretty common to want to use a column data source from a Pandas data frame. And so we've made it pretty easy to do that as well. If you have a Pandas data frame, in this case our monthly values, you can just pass that data frame to column data source. And now you've got a column data source that contains that those Pandas series. And it doesn't copy the data, it's just got references to those series. So it's very efficient to create this. We can actually take a look. If we look at source.data.keys, we can see, sure enough, all the columns in our data frame are now over here as well. So month, passengers, freight, mail, and month name are all the keys in our column district. Yeah, question. So the question is there a memory limit? Explicitly, no. I mean, it's really up to whatever you have available. Obviously, this being a cross-runtime library, going from a Python process to ultimately your browser, there's going to be some overhead for transferring. And so if you store 100 million objects, those are going to need to be serialized, sent into the web page and deserialized. That's probably going to be too big and it's not going to work. It's really kind of dependent upon context. We do have some options for showing larger data sets that can handle drawing things, but again, ultimately the data has to get into the browser. So it's sort of up to the browsers, which are all different and unique in their own ways. So it's hard to say anything specifically, but ultimately you can put in whatever you want and you'll have to sort of evaluate if it meets your needs. Certainly there's plots in the examples that show tens of thousands, hundreds of thousands of points, and even more is possible sometimes. But anyway, good question. Other question? That's actually a good question. I expected to see that there. I'll have to come back to that as well, because I don't remember, something may have changed since I last looked at this. I know it is possible to have that index and for it to show up. I'm not sure we add it by default anymore, but we might. Actually, I think if the... Oh, yeah. Yeah, I guess there is some special handling index. I don't know. Let's come back to that at the break. I'll have to maybe actually do some research for that one. Okay. So there we go. Okay, so let's take a look at another example. Again, we're going to use a column data source here. We're going to create a figure. In this case, we're doing the V-bar plot. So we're going to need a categorical X range. So we need to specify what our X range is in terms of the sequence of categories, how we want them to show up on our X range in our X axis. And then we call V-bar and we give it, again, X equals month name. The top is going to be the freight value from that column data source. We can pass it a fixed width for all the bars to use, and we pass it the source. Same thing here. We're going to create a second V-bar. It's going to be stacked on top, and we're going to manually stack it in this case, but there is actually a V-bar stack that can be used as well. But in this case, we're going to use the mail. We could use passengers, but let's take a look at what this looks like. All right, so we could change that if we wanted to, and I'll give you just a second to tinker with this. If you wanted to do, for instance, mail instead of passengers, you could uncomment that, comment that, and you would see different values being used for the plot. So basically, column data source is a way to add a level of indirection, right? To reference the data in this other structure as opposed to passing the data just directly. And again, that's very useful for a number of different situations. Okay. All right. See if we're on time.
A question real quick.
Yeah. What? Yep. Question.
How would you handle multidimensional data if you're given the labels that you want to plot, x-axis, y-axis? Let's say it's a 2D structure. Will it interpret it?
No. So there are some data structures that require 2D data. I don't know that we're going to see them maybe a little bit later in the tutorial. For instance, image plots, right, require 2D data. There's actually a recent image stack that was added by Ian that can represent stacks of data, visual data. There's also contour data accepts, I think, 2D data. In general, Bokeh is not going to flatten anything. If you need like a scatter plot, and I think if you're asking like if there's multiple columns of data in a 2D array for a scatter plot, that you'd want to probably flatten yourself. It's not going to automatically happen. So yeah. There might be other higher level tools built on Bokeh that do that, like Holoviz, for instance, is kind of high level. Yeah, Ian?
Something like multi-line effectively takes a list of
Yeah.
blocks that could be pixelated 2D.
Yeah, so besides the images, there's also some multi-glyphs, like multi-line, which take basically ragged arrays, so a list of lists or an array of arrays, but those are specifically like a list of arrays, and then it'll draw multiple lines for each one, but that's not, it doesn't accept like a 2D array and then pull that apart. You have to split it into separate sublists, so yeah. Cool, good question. All right, cool. All right, so the last thing in this section, just mentioning a couple of options here for transforming the data. There's several different transforms that are built in, but let's take a look at a couple in particular. So we saw in the last chapter, linear CMAP from Bokeh.transform. Besides that, there's also a cumulative sum. So this is really useful for pie charts, as we'll see in like the next chapter. But there's this cum-sum transform that allows us to sum all the values in a column and use that to drive the input sort of dynamically. And again, this computation happens in the browser on the JavaScript side. So let's take a look. So we import our transform from Bokeh.transform. We create a data source that has our monthly data values from our data frame. Here's our plot. Set our X range from the month names. And now we call vbar. And so in this case, we pass X as the month name for our X coordinates for the bars. A fixed width, here's our data source we pass in. But now we pass in the cum-sum transform, and we tell it we want to cumulatively sum the passengers column, and let's go ahead and add this include 0 and see what that looks like. So in this case, I guess this would be maybe the passengers at the beginning of the month, because we've called include 0. We could leave out include 0, and it would not do that. This would maybe be passengers at the end of the month, and we can see that. But again, this summation is happening in JavaScript in the browser. It's not happening in the data in the Python side. And again, we might want to tweak, tweak x-axis dot major label. Or something, and we can use that to tweak. Again, all those visual properties apply on any plot you might want to create. Okay, the last one here, we saw this briefly in the last chapter already, but I just wanted to highlight that it is one of these transforms. Linear CMAP, so again, it's also from Bokeh.transform, import linear CMAP. And now we're using the column data source. So whereas the last chapter we used it sort of with data we passed in, so we just said transform the Y column. That's because Bokeh created a column data source with a Y column for us. In this case, we're passing in our own data source that has our own values, column name. So we could say, for instance, X values here, just to make it completely explicit, what goes where. And let's run this. We can see that we've color mapped according to the X values, right? And so our linear CMAP transform here refers to the X values column of our data source. We want to use this Viridis palette with sort of a min and max cutoff of 0 and 100. We can see what changing that looks like. Let's change it to 200. You can see now the values all fall at the lower end of that color map palette. So that's what those are used to control. But yeah, there's several transforms in addition to this. And it's also possible to create your own transform. So in Bokeh, just as a sort of preface, you'll often see objects that have names like custom.js or custom.js something, in this case, custom.js transform. Basically, you can provide a little snippet of JavaScript, often just a couple of lines, that can be used to define an arbitrary transform that will do whatever you want it to do in the browser. So that's often very powerful. So you could define a transform that does pretty much anything you want to a data column in the browser using a custom.js transform, and that's all on the docs as well. Okay, so I think we're not too bad on time. Let's go ahead and move on to the next section. Okay, adding annotations. Well, first, any questions about the last section before I move on? Okay, we're going to do this section and one more, and then we'll take another break. Okay. Excuse me. So adding annotations. So besides these glyphs that we've seen, there's often a lot of other things you'll want to add to a plot to sort of guide your viewer to sort of, things that are interesting to view or to point out certain things about the plot. And so we call those things annotations. And currently, Bokeh has basically objects that specifically represent annotations. I think sort of going forward in the future, we may see a little bit of a change there and think about annotations more as something you do, basically using glyphs. But All of this is very good information and will be for a very long time. So we'll talk about what some of the annotations look like right now. So the first one we'll talk about here is a span. So a span is just a line that crosses the entire dimension of the plot, however wide or tall it might be. It'll always span the entire dimension of that plot. So, you might want to use that to mark the top value or the minimum value of some range of data or some other region of interest that you want to call out. So we can take a look at that. We're going to do our imports, create our figure, get our data frame, and we're going to do some work on the data frame, and then we're going to call line with X and passengers. We're going to format our ticks with this numeral tick formatter, and then we're going to add 2 spans. And we're going to use these spans to sort of mark the maximum value of the data and the minimum value of the data. We create these span objects. We call this plot.addLayout method. Kind of think of that as boilerplate. It's just plot.addLayout. You're going to add these annotations using this addLayout function, and then we're going to show it. And so if we look at that, we can see, sure enough, our red annotation for max passengers is right up here at the top. And our blue annotation, our blue span for min passengers is down here at the bottom. So again, spans are very useful. There's also things like bands that you could use for confidence bands, similar annotations like that. All of those are documented in the user's guide. If we go to annotations here, we can see there's quite a few arrows, bands, box annotations, polygons. We'll see a few of them here in this tutorial. Okay. Just to know where the spans are going to go, there's this dimension property. So if you want the span to go across the width of the plot, dimension equals width. If you want the span to go vertically across the height of the plot, dimension equals height. Take a look at another example here, some vertical spans. Since spans draw lines, they have all the standard line visual properties that you could pass to any standard line. In this case, we can pass like line color red, line width to, line dashed in this case to make them dashed spans. And you can see that our red span here at location 2, sure enough, and our blue span here at location 7, so that's just the coordinate we want the span to be at, right here at 7, right? So same as the previous example, pretty much just a different dimension. Okay, labels. Another really important thing very often for plots is to be able to label things. That could be labeling individual values, that could be labeling every values, attaching labels to bars, all kinds of reasons you might want to label things on your plot. Very important. So let's take a look at what that looks like with Bokeh as well. So the first thing is we need basically a single label. You can place that individually using this label annotation. So it takes an X and a Y properties. It takes the text that you want to be on the label. Importantly, though, it also takes things like an X offset and a Y offset. So you might imagine wanting to label like a specific data point, but you don't want the label to overlap with the scatter plot. So you can offset that by a certain amount. So that's what things like X offset and Y offset are like. Because it's text, all the standard text visual properties apply. Text font size, all of those things. Okay, so again, it's placed at the same coordinates as the data points, modulo any X offset or Y offset or baseline changes that you add. So let's take a look at adding a couple of label objects specifically here. Again, we'll use this add layout function to add our data labels. The first label is at 5 and 7, has some text maximum, has a particular color. The second one here, again, is at 5, 5, X and Y 5, 5. Different text, different font size, and if we take a look at what those look like, we can see, sure enough, the source Bokeh user guide label here is just down at the bottom. Here we've specified screen units. That's how we can make it sort of absolutely at the bottom of the plot here. And then here, by default, the X and Y values are sort of data units, the units that the glyphs are plotted in. And we can see we've labeled this specific point, with maximum. And we've done that manually. But we can also attach multiple labels sort of more automatically, and we'll see that in a minute. All right, so I'll give everyone just maybe a minute, since there's a few different options here, to play around with these, and then we'll move on. Okay, hopefully everyone's had a chance to sort of play around with that, so we could imagine changing the X offset, in this case, to something much larger, 22, and we can see that now the label is shifted to the right because we had a bigger offset. We could also add a Y offset, right? So if we wanted to shift things a bit in the Y direction, we can say Y offset equals 5 and see what that looks like, and now the value is shifted up a little bit. So again, it's important to note these offset values are the units there are pixels. They're sort of in screen units, the canvas units, right? Which is not the default for the actual coordinates, but is the default for the offsets. Okay, so Oftentimes, though, we might want to place multiple labels relative to our data points, just a bunch all at once. And so in that case, we have sort of a vectorized version of label called label set. And so that can be driven by a column data source. So we saw how the column data source can be used to drive all of our glyphs sort of automatically by saying, take your X from the X values column and Y from Y values. In this case, we can use a column data source to drive this label set annotation as well. So we've got our column data source. It's got temperature, pressure, and names as the different properties there. We create a figure. We call scatter. X is the temperature. Y is the pressure. We pass in our source so it knows where to get that data from on the JavaScript side. We change some labels for our axes, which is always good to do. And then finally, we add a label set. So in this case, we say that we want the labels to be X is temperature and Y is pressure. We also want to offset them so they're not actually overlapping with our data points. So X offset equals 10. We can change the baseline. But in particular, we say that we want the text to come from the names column. So that same column data source that drove our glyph can drive this label set. But if there are any additional columns, like this names column, that the glyph is not using, the label set can use them just fine. So in this case, the text comes from the names column. We call add layout, and we show things. And sure enough, all of our different values here that are scattered using the scatter method are now labeled using the names that correspond to them in the column data source. I will mention in passing, there have been some recent enhancements to a text glyph. So we have a text glyph, just like there's line and circle. There's a text glyph, and probably in the future, we're going to encourage people to use the text glyph as the basis for sort of annotating things with the text labels, because it'll be a bit more flexible possibly. But that's just a preview of maybe things in the future. All this will all be available for a very long time, and this the text glyph will only be able to do more at some point in the future. So, okay. Lastly, here in annotations, another useful one is arrows. So there's a couple of different options here for arrows. There's different types of arrowheads that we might want to add. So you can see Bokeh built-in supports 4 different kinds of arrowheads. And those can be on either end of the arrow. You can have the arrowhead at the start or the end or both ends of the arrow, and you can add that. To add that, you create an arrow annotation, and you specify which type of arrowhead you want on the end in this case, where you want the arrow to start in X and Y coordinates, where you want the arrow to end in X and Y coordinates. And let's just take a look at a quick example. Here we've added an arrow with an open head, and we can change, again, all of the properties of the arrowhead, line color, line width, all that sort of thing. We've told it where we want to start at 20 and 6,000, right here, 20 and 6,000, and where we want to end at the bottom of this parabola right at 0, 0. And then we add layout, and we add it. I will mention in passing, one of the things that people have asked for is a vectorized arrow. We don't have that yet. Hopefully, coming in not too distant future, would be an arrow that can be driven by a column data source. So you could have a lot of arrows very easily. Right now, you would need to call arrow to add individual arrows to your plot. Okay. Okay, doing good on time. All right, last section before break. Well, any quick questions about the last section first? All right. Cool. Last section then before break, talk a little bit about plot tools and tooltips and that sort of thing, because those are really important interactive aspects of the plot. So we've seen that if we create just a sort of generic plot, Bokeh by default decides to add some default tools that are available. Typically that's things like a pan tool, selection tool. This little symbol here is the scroll zoom tool. There's a tool for resetting the plots to its original range and that sort of thing, help tool. So Bokeh will just sort of create those by default, but we can customize those pretty much however we need to. So the first thing we might want to customize is just where the toolbar appears. By default, it appears on the right side of the plot, as we've seen. But here you can change the toolbar location and set it to below. And if we do that, we can see, sure enough, the toolbar is now below. In this case, it's a little clunky, I think, because the axis is also below. You could move the axis up. Or not have an axis down below, and then the toolbar would sort of move up snug to the plot. But you can also have it this way as well, if that's what your application needs. So I'll give you a second to play around with the toolbar location and set it sort of different values. Another common one is if you simply don't need a toolbar at all, toolbar location is none, and now there's just no toolbar. So. All right. So how do we tell Bokeh what tools we want? There's a couple of different ways here. There's individual objects that represent each tool, and we can certainly add those to our tool parameter for the plot. But there's also these nice convenient name aliases that we can also use as well for sort of default configured tools. Some examples here, there's like the pan tool, which allows you to sort of click and drag and pan the plot around to different regions. XPan or YPan are pan tools that are restricted to the X or Y dimension respectively. There's tools for wheel zoom. There's tools for just clicking the tool to get like a zoom in or zoom out by a specified amount. Save plot, reset plot, that sort of thing. So let's take a look. So we can just pass all of these names to our tools parameter, to our figure function. And if we do that, we can see that now this plot only has this subset of tools. So what are these? So here's box zoom. So this box zoom is used to drag. Oh, I turned it off. Used to drag a region, and then we zoom into that region, right? So that's sort of the purpose of a box zoom tool. Don't have a reset tool here. Let's add a reset tool. That'll be helpful. So now if we do this and I do a scroll zoom and zoom into some other different region, I can hit my reset tool and it'll reset back to the original range bound. So that's what that tool is for. Also, just to mention, the save tool here is able to save, if you're using HTML Canvas, which is the default rendering for Bokeh, the save tool can save sort of a click to download version of a PNG from here. You can enter the file name and hit OK, and it'll save a PNG. If you want to create export from Python code, we'll see that a little bit later in the tutorial. Yeah, question?
Does the reset feature, does it actually reset the plot, or does it generate a new plot based on the original order?
Yeah, good question. Does the reset tool actually generate an entire new plot, or does it reset the existing plot? And it's the latter. It resets the existing plot. In particular, it resets the bounds back to their original locations. If you also have any selections, which we haven't really seen yet, if you have done any selections with like a lasso selection tool or anything like that, the selections are cleared as well. But that's basically what a reset tool does. Yeah. All right. It's also possible to define active tools. So Bokeh classes tools into different sort of gestures, right? There's like a drag gesture, which is what you might do when you're panning or if you're drawing a selection region. Inspections are sort of passive tools that just happen anywhere the mouse happens to be moved. There's the scroll tools and then tap tools when you either tap or click a mouse button. There's several tools in each category, and if you add all the tools, Bokeh will sort of has a default order within each category. But if you want to be specific and say, I want this particular tool to be the active tool when the plot is initially displayed, you can set the active drag, active inspect, active scroll, and active tap. So in this case, we'll draw a plot here, and we have the pan tool and a YPan tool and an XPan tool, but we've specified explicitly we would like the XPan tool to be the active drag tool. So I can't, if I move up and down here, it's not going to pan up and down because the XPan tool can only pan the X-axis, and you can see that's the one that's active by default when the plot initially is started. So that's what the active properties are for, and I'll go ahead and let y'all play around with that as well, just for a few seconds here. So we could change this to YPan. And now the YPan, I can't scroll left and right, but YPan is active. But of course, I can change the selection to do that after the fact. There's an example there. All right. Okay. We're pretty good on time, actually. So let me go ahead and move on to the last topic here for tools. There's more tools that we're going to cover here in the tutorial for sure. In fact, I might go over to the docs and just find a few examples to show some of the ones that are available. But one that we want to go into in more depth here is for hover tools. So that's basically if you hover your mouse over a data point, you can get some additional information or context about that data point. So that's a pretty useful technique for data visualization. So let's run this example and see what it does, and then we can go back and talk about. Okay, so this generates our plot. It's a line plot with some scatter markers at the same points. And if I move my mouse over this data point, we can see it tells me this data point is at 3,8, and this data point is at 2,7, and this data point is at 1,3. So how is that accomplished? In the simplest case, the simplest way to add a hover tool is to pass the tooltip's value parameter to figure. And in this case, I've said data point is at, and then this is the sort of specific Bokeh thing. Data point is at X, at Y. And so in these tooltip format strings, anything that's prefaced by this at symbol will reference the column data source, which is, again, another reason why it's useful to be able to know how column data sources work. So we've created a column data source with an X column and a Y column. And so at X means when I hover over a point, find the X column value for that point, and find the Y column value for that point, and display that in this formatted string. And so we see exactly that down here. We see data is at 3,8, or 6,2, or 9,1. And that can happen with any other, if we have additional column, that would also work as well. So we could do, at name instead of Y, right? And so that references the name column. And we can see now, we see that it gets the name column instead of the Y columm. So again, it's just this mapping of mapping things to columns and addressing those columns, in our hover tooltip. So that is the simplest way. It's also possible to create basically a tabular hover tooltip that has basically a table of a label with some formatted string. And we can provide that in a different way as well. Let's take a look. In this case, we configure our hover tool directly. And the tooltips in this case is a list of tuples. And so there's the index. Keep doing that. We want a row that says index, and we want the index into the, into that row. Basically, is that the ith circle, the 10th circle, the 11th circle. We want a label that says x, y, and we want the x and y positions as well. Let's take a look. Let me actually see if I can find one from the gallery. Hover tools. We recently reorganized our docs, so it's takes me a second to find things. Plot tools down here. Here we go, and we can go to inspectors, hover tools. So here's an example of a lot of examples in this tabular format. But just to show you what that looks like, the tabular format looks like this, right? So we've got basically a table of rows. There's the index. This is the second point. The x and y position is those values, and some other column description is that. And so as we hover over each one, we get that sort of table. I just wanted to make sure people know what that table, the result looks like. It looks like this sort of tabular value. And up here, we can see this larger table that has like quite a few rows. And so that's using this tooltips where you give it a list of tuples, and each tuple is a row that has the label and the formatted hover tooltip string for that label. So that's pretty common as well. You'll see a lot of examples in the gallery that use that. But again, the simplest way is just to provide this tooltips directly to figure. So if you have a simple case, this is definitely the easiest way. Okay. A few other things to mention. It's possible to apply formatting to the hover tooltip values. So basically here at X means we want to display the X column for each point, but we also might want to display it with this format. Here we might want to have a different format. Here we've used this thousands separated format. All these formatting tooltip fields are described in the docs, but we can just sort of see what they look like. If we go up here and do at X, and we add a 0.000, now we've got this floating point format that we've asked for. So that's, Bokeh's got this kind of particular specific to Bokeh formatting language, but that's really because this is a cross-runtime project. We can't really just use, if we use some JavaScript format, that would be sort of different for Python users, and if we just use some Python formatting language, we'd have to sort of implement that in JavaScript. So we've got sort of this specialized formatting language, but it's fairly simple. At always means refer to this data column. You might have also noticed that there's also the $ here in the couple of cases in this example. Anyone that starts with a $ we call a special variable, and those are just built in and supplied automatically. If we go to this example here, you can see $x and $y. That actually means the x and y position of the mouse, not the data point. Or you can get things like the color. So anyway, all of that's in the docs. I just wanted to mention it, at least in passing. Okay, so let's take a look at a hover tooltip example for our actual data set that we're going to be building our dashboard from. Here's our biggest airlines by passengers, right? So we can sort of see the top of that data frame. It's got a couple of columns: unique carrier name, unique carrier, which is a code for it, passengers, and their position rank, okay? So we can create, again, numeral tick formatter, a tap tool here we want to use. We want to get the biggest airlines by passengers, and now here's our tooltips, right? So we want to show the position, and we want to refer to the position column for that. Sort of, what rank are they? What's their unique carrier name? And then we want the number of passengers formatted using this sort of thousands numeral tick formatter. So we create our figure. Again, it's got our X range, categorical X range. We pass in a title, we pass in our height here, height equals 300, and importantly, we pass in the tooltips. And I guess I should mention, yeah, it's possible to specify the sort of tabular format as directly to tooltips as well. Okay, so now we create our vertical bar chart. Again, we're passing in a data source so we can reference, the unique carrier name for our X coordinates. The top of the bar should be the passenger's value. Excuse me, some water. And then we give a width. We change some other configurations just like we've done before, and if we show what that looks like, here you go. Position 1, and it's the name of the carrier, and it's formatted using that nice numeral tick formatter. Here's position 2, position 3, and sort of all the way down, position 10. And we can see all those formats have been applied the way we want. So that's a little bit of an idea of what's possible using hover tools. Just like with everything else, there's things like a custom JS hover that you can use to format the fields exactly as you want, especially if you need to do formatting that's contingent on some other field. You can use things like that. Again, sort of arbitrarily complicated formatting if you need to do. You'll see examples of that in docs and examples as well. But anyway, that is plot tools, just as an example. Wrapping up here, some other really interesting tools that you might be interested to look at in the docs are things like selection tools. So let me actually just find an example from the gallery just to leave with, because that does show up quite a bit, is we might want to have selection tools that allow you to select specific, that was a zoom tool, a selection tool, I think it's that one, select a different region. And so we can sort of see that the appearance of the selected versus non-selected looks different, and we can configure that. But we can also get the indices for the selected versus non-selected, and there's a lot of examples of that in the docs and also in the examples gallery as well. So anyway, that's another, I think probably one of the more common tools, and then if you go to the actual tools section in the docs, you can see pretty much everything. So anyway, any questions about this last chapter for plot tools? Yep.
Is it possible to override or get a Python callback for the tool and then override the Bokeh action?
So yes and no. So if you're using a Bokeh server, so if you're creating standalone output, you're creating just the JavaScript, you run your Python code, it generates the JSON, it goes to the browser, the Python's long gone. It's not in the picture anymore. And so you can have JavaScript callbacks that can get the selection indices or do whatever you want to do on hover, and you can do JavaScript code in those custom JS callbacks. If you run a Bokeh server, the Bokeh server is that Python process that could be connected sort of bidirectionally, so that if you click on something, a Python callback happens, or if you make a selection, a Python callback happens. And we'll get into that a little bit in this tutorial, but it's kind of an expansive topic. A great place to go for ask for help or questions about that sort of thing is discourse.bokeh.org. We try to be pretty responsive there, but there's also an entire chapter about Bokeh server in the user's guide.
Without getting into it though, by server you mean the service?
Oh no, you would run Bokeh. It's kind of like running the Jupyter Notebook. You'd run Bokeh serve and your notebook, or Bokeh serve and your application code, and then that's a server that's running that people can connect to see the web page that you've created with the content in it. And if they make selections, then you can run your callback code in that Bokeh server process. But just for reference, that chapter, the user's guide is Bokeh server. There's an entire basically section with several subchapters for Bokeh server. It's a big topic, but. Okay, I think that's just about time, so we'll go ahead and take a 10-minute break, and we'll come back at 46 or 46 after the hour. Alrighty, well, welcome back, everybody. I have one more quick chapter to go through. Just a couple of examples here, and then Ian is going to be taking over for the remainder of the tutorial. But I did want to do this as well because it's going to be showing up in some of the later chapters building our dashboard. Okay, so we've seen how Bokeh has this figure command for sort of generating a generic plot, the kind of thing you would use for a line plot or a scatter plot or a bar chart or anything like that. But there are some more specialized kind of charts that come up, and let's see how you might create those in Bokeh, right? So we'll do our standard two cell executions here. Output notebook. So in this case, we're going to take a look at some map plots, some options for map plotting in Bokeh, and also wedge plots, sort of pie and donut charts. So there's a couple of different ways to create map plots in Bokeh. For this tutorial, we're going to be looking at tile provider plots. Bokeh uses a library called XYZ Services to manage sort of the tile providers. It's a project that aims to be sort of a consistent way to refer to all the different map tile service providers and make those services accessible. So we use that, and you can use a variety of different tile service providers, CartoDB, OpenStreetMap. Some of them may require like an API key, for instance, but it's still a consistent way to access them. So we're still going to use our figure call here. We're going to set the X range and Y range. Important note here, those ranges need to be specified in sort of Web Mercator coordinates. It's a little clunky. This is, I will say, maps in general, probably an area where Bokeh could really benefit from some folks who have GIS experience and have really strong opinions about what a great UX for maps would be in Bokeh. But this is what you can do today. And certainly we'd love anyone to come help become a contributor and help make things even more smooth or better. But anyway, X range and Y range, Web Mercator coordinates, X-axis type, Y-axis type, you're going to want to set that to Mercator to see nice sort of lat-lon values. We're going to create a tile service provider object, then we're going to pass it to add tile. And on top of that, we can call standard functions like line or circle if we want to add our data on top of the map plot. So let's take a look at what one of those look like. So we create our XYZ services or import XYZ services. We create our import figure and show from Bokeh as usual. We create our figure plot, and again, here our X range and Y range are sort of in these Web Mercator coordinates, which are technically meters really. Here's our X-axis type Mercator, Y-axis type Mercator. And let's add a tile. So in this case, we're going to add the CartoDB positron map. We're specifying we want the retina versions of those, or high-res versions of those tiles. And we see what that looks like. Sure enough, here we can see sort of that CartoDB positron map. So give everyone a chance to sort of play around with this, but I'll go ahead and do some of that as well. Take a look at some Esri imagery again. Now we've got a retina display here. And so again, we can zoom, standard tools, all that works fine. We can do a box zoom, we can do panning, we can hit our reset tool, all that's fine. If we want to plot, circles or any other glyph on top of this, regions, our sort of polygon glyphs for regions, any of that's fine. We can plot that on top of these map tiles. Okay. So yes, there's a whole section in the user's guide about tile provider maps. I will just mention in passing, in addition to this, there is also some, I would say, minimal GMAP support, so you can actually have a GMAP plot underlying this. Those are a little, I would say, a little bit different, and there's some limitations there, but just mentioning the possibility. If possible, tile provider maps are probably the best thing to look into first. Let's see. Tile demo actually shows all the different, sort of a bunch of different tile providers that are sort of common, I guess. So you can see sort of this grid plot that has, different CartoDB tiles and Stamen Toner, all of these different tile providers, easy to add from Bokeh, and you can see the code here. And again, the gallery is actually a really great sort of visual index, at least for me. Definitely encourage anyone to look at the gallery. It's a great place to sort of try to find a plot that looks kind of like what you want, and then you can click on it to see what the code for that might look like. So just reiterating what Timo mentioned earlier, the gallery is a great resource for that. Okay, and as I mentioned, Bokeh also supports Google Maps. Again, Google Maps several years ago required the use of an API key, so that's why we don't have an example here. If you want to create a Google Map, you'll have to have your own Google API key and provide that as part of configuring the plot display. But you can see an example in the user's guide. If you go to, let's see, topic guides, geographical data, there's Google Maps here, and you can sort of see, here's a Google map with some data drawn. It's a little weird. If anyone knows how to fix this, I'd love to know. This just started happening several years ago, this lag. I tried fixing it and I couldn't. So anyway, but that's there. Again, you would need a Google API key of your own to use that. Okay, going back here. Along with the tile maps, though, some things that are typically useful are GeoJSON data source. So if you have data that's already in sort of GeoJSON format, you can take that data and sort of add it to a GeoJSON data source, which is kind of like a column data source, but useful for these kind of plots. So in this case, we're going to create a point, location of the UN headquarters in New York. We're going to create a feature with that point labeled. We're going to create a feature collection with that. And now we can look at what that looks like. This is what sort of GeoJSON looks like. Again, we need things to be in this Web Mercator coordinates. So it's a little bit of a manual process now. We're going to use GeoPandas to actually do that conversion. So here we create GeoPandas from features. So we pass it our GeoJSON. We tell it to do this conversion, and then we sort of dump things back out. And again, now we have our data source that sort of references Web Mercator. And so we can pass that to our GeoJSON data source. Again, our Bokeh.models import GeoJSON data source. And now, if we add a circle, we can use this GeoJSON data source, right? And we can reference the X and Y positions that are in this GeoJSON data source. Let's go ahead and take a look at what it looks like. There's our UN headquarters in New York, the UN colors. And again, we can pan and zoom and everything moves around like we'd expect. So again, this is a little bit, I would say, manual, some of this at this point. It would be great to have some folks with opinions and experience about GIS use cases to come help us improve this even further. But we'll see some example here. We have our GeoJSON for our data. Note that this particular plot right here that I've just plotted using the geodataframe.plot, this is generating a matplotlib plot. We're going to try to get a plot like this in Bokeh that also has some interactive features. So just being aware that this right here literally is a matplotlib plot, which is great. But let's take a look at what our geodata frame looks like. See, it's got an origin and a destination. We're sort of talking about routes that are leaving or arriving in different states. And we can sort of join that together with the name and with the actual boundary data for the state. And we can see we've got this now new data frame that has the name, the boundary, and again, those origins and destinations for routes. And so now that we have this sort of geo data source, we can use that to drive our tooltips, just the way we could with the standard column data source, right? So let's go ahead and plot this first, and then we'll take a look at some of the code, because this one's a little bit more involved. So we'll plot that, and so now we've got our plot, and now we can see that each polygon for each state has a hover tooltip with the name of the state and the number of routes that are departing. And so just the highlights of this code here, we've got our data for getting in our GeoJSON data source, but our tooltip specification is exactly the same as before, right? So we want the state as the label in our tabular tooltip with the @name column from that GeoJSON data source, and then our label is number of routes departing, and again, @origin, right? So we're just referencing that origin quote-unquote column in the GeoJSON data source. All of this is fairly similar to other stuff we've done before. We've created a figure. We've configured a title. Here we're setting our toolbar X and Y axis locations to none because we want to not show those. We've turned off our grid colors, other configurations like that. And then the last thing to mention here that's probably important is that the thing we want to actually use to draw these, since these are sort of polygonal data, is the patches. So there's a couple of different options for drawing polygonal data in Bokeh. One of them is patches, which will draw sort of polygon patches, and it's driven by this geodata source. And again, we can apply that same linear color map that we used in previous chapters to say, I want to use the origin, which is the number of departures from that state, and I want to color map it according to the Civitas color map, and again, we pass them in and max, and we can see that it color maps according to that. So yellow is going to be very high, and California and Texas have a lot of departures. Lower values here. I'm from Oregon. I can see sort of color map in this darker hue. Okay. Again, we also construct a color bar using the construct color bar method we saw demonstrated earlier. So this is the kind of thing we're going to put in that nice dashboard. And you might see this, similar to other dashboards with this kind of styling where there's no, we want to turn the grid off, and we want to sort of have a sort of minimal styling around the map, but then still be able to have this interactivity. Okay. All right, last section here before Ian will take over, talk about some wedge plots. So another common kind of thing you might see are sort of pie charts or donut charts. And so just how would you create those using Bokeh? Again, here let's have a data frame. This will be our pizza data frame. Sort of ordering things by toppings. So we've got pepperoni, cheese, mixed veggies, and bacon. And we've got the number of orders that have each of those kind of toppings. And then we have maybe a color that we want to use to represent each of those toppings. And we can look at our pizza data frame here and sort of see it's exactly what we expect. We can imagine if we want a pie chart, we would actually sort of need to create the angles, right, for the wedges that represent that pie chart, pizza pie chart. I just got it, Timo. Thank you. Great. Okay. So we can put that in a column data source. Here, that cumulative sum transformation is really useful because we can use sort of the angles for the start, and then we can use the cumulative sum to sort of angle each successive wedge further along. And right, so let's take a look. We've got our pizza data. We put it in our column data source here, and then we again create a tooltip. So we want the topping name and the number of orders that had that topping. I guess here we're assuming the toppings are mutually exclusive, and that's fine, good for example. We got some styling for the the colors and other visual properties. And then how does our wedge actually look? So wedge is the actual glyph. So just like line and circle and other scatter glyphs, wedge is just a glyph that draws a wedge, and it takes a x and y coordinate as the center, sort of the point of the wedge. It gets a radius. This is going to be in data coordinates. And then it has a start angle and an end angle. And again, these can be vectorized just like the scatter plot. You can sort of vectorize over x position or y position. In this case, we're saying every wedge has its own start angle and end angle. And again, we're going to use the cumulative sum transformation to say that angle should be, the successively greater angle for each wedge. Change some more visual styling. We pass in our pizza data as the data source. And we can see what that looks like right here, right? So for the first wedge here, the angle is going to be 0, and then we're using the cumulative sum transform to make the start angle successively bigger for each one. And so that cum sum transform is pretty useful for pie charts. Comes up pretty often, specifically in that context. Okay. Apart from pie charts, another thing that maybe, at least in my estimation, seems to be even cooler, I guess, for dashboard type applications or donut charts. I seem to see this a lot. And this is where instead of the actual sort of wedge, you get this sort of annular region. And so here's an example of that same chart using the annular wedge. And so the only difference here is that we've used now, instead of the wedge glyph, there's an annular wedge glyph, and it takes the same x and y center coordinate. But instead of just a single radius, it takes the inner radius and the outer radius. So in this case, the inner radius is 0.2 and the outer is 0.4. So if I do 0.3, now it's a much sort of skinnier donut chart. Or we could do 0.2, and you can sort of see it changes. So that's really the only difference from that example to the previous example, is that now we have this inner and outer radius for this annular wedge glyph. And so for our dashboard, last thing to show here is just what that looks like for our dashboard. So we get our passenger biometrics. We're going to want to put all of this together, and we're going to want to create a couple of different annular wedge charts. Again, we're going to use the cum sum transform here to sort of transform those angles and have different wedges sort of at successively further distances. But we can add our standard tooltips in the same way as we added before and see, this one is for carrier, this one is for Delta, this one is for United, and we can see, the number of passengers along with that. And so we've also added our legend there on the side as well. So anyway, that's that example, and this is the example that's going to show up in our dashboard. And so you can sort of see all the different parts put together there. Again, passing tooltips to figure, using cum sum for sort of our wedges or annular wedges as pretty common, and then of course styling it in the style that we want using all the configurations we saw before. So that is pretty much all I have for this chapter. Any quick questions about this chapter? All right. Well, if not, I'm going to turn things over to Ian to round out the last part of our tutorial.
Thank you, Brian. So I will be presenting the last few chapters in the tutorial. Aiming for about 45 minutes to go, then it'll be free. But after that, we'll do a little question and answer session for anybody who wants to hang around anymore. Feel free to submit questions in advance to the Slack, or you can just put your hand up, at the time, whatever you want to do. Right, drink first. Notebook 10, layouts. So our usual start with some imports. This chapter is about how we combine multiple plots or other widgets, other user interface elements into the same output. Up until now, we've generally dealt with a single plot per example, and it's nearly always had a fixed width and a fixed height. It doesn't have to be quite that controlled. We can vary it, do things differently. Sizing modes. So there are actually 3 different sizing modes. We can have a fixed mode, where let's not do that, where we specify the width and the height in pixels, in screen units, and I think we've done that every example so far. Right. There's a stretch mode, where we can stretch the width or the height to fill the available space, and we'll have to explain what the available space is. And a scale mode is like a variant of a stretch mode, but it maintains the aspect ratio. So things get smaller or bigger, but keeping the X and Y ratio in the same the same constant. First example is fixed mode, which we should all be familiar with. So we have here single figure. We've got a height of 200, reasonable number. We've got a width of 4,000, probably not a reasonable number. My screen's only about 1,000 pixels wide. But it does what it's told. So it's drawn us a plot which is very, very wide, and we have a scroll bar to go through that. So that's probably a mistake. I've got some examples, some reminders here to try some smaller numbers. Perhaps it would be more reasonable to try a width of 400. Sure enough, we can therefore see the whole plot. If I vary the width of my browser, it should have no effect whatsoever. So if the browser is, say, 400 or 500 pixels wide, we're okay, we see the full plot. If we go smaller than that, then the plot gets smaller and we have a scroll bar to look through it. That's not ideal, hence the other options. Stretch mode. So that was fixed mode, this is stretch mode. In stretch mode, the plot or widget stretches to fill the available space. And we mean by that the space provided by the container, the parent, the object that contains whatever we're looking at, because this applies at multiple levels, as we'll see shortly. Stretch width is the most common. Stop doing that, Ian. Here, the component width resizes to fit the available space, but it only affects that particular dimension. So stretch width varies the width only, but the height stays controlled by its own setting. Stretch width is quite a sensible option for notebooks, as we will see. Stretch height does the same for height. Now that works fine in standalone HTML documents where you would typically look at a single page at a time, but for notebooks we have this idea of cells flowing one to the next, and there isn't really the concept of a fixed height. If you ask for a stretch height in a notebook, you'll get basically 0 because the container doesn't have any size. And then stretch both applies both stretch width and stretch height at the same time. Again, we wouldn't want to do that in Notebook. So we're in Notebook. Here's a simple example of sizing mode. We have specified for a single plot the height and the width in number of pixels. In fact, the width is ignored. The sizing mode stretch width tries to occupy as much space as is provided by the container. So the container in this case is in fact the div, the HTML div element that contains the plot. If I make the browser a bit smaller, the behavior now is much more reasonable. This is probably what people want to see. You go smaller and smaller, the plot gets smaller proportionately, and we don't get a scroll bar. And we've just got an example here. If we went back to fixed, of course, that will stay at the fixed width of 400. So sizing mode, stretch width is quite sensible. Scale mode, scale acts like stretch, but it keeps the aspect ratio constant. As before, because stretch mode only really makes sense in a Jupyter Notebook for width, not height, so does scale mode. Again, an example is much more informative. So we have, again, a single plot. We're specifying the width and height in pixels. Those values are important for height because that's going to specify the height of the plot, but the aspect ratio is the ratio of those two numbers. Let's look at it. So at this stage, it looks the same as the previous plot. We've got scale width. If we go smaller, though, sure enough, the plot gets narrower. But as it does, it also gets smaller in height, so we keep the same aspect ratio. It gets a bit silly when we get small labels overlapping. So that was sizing mode, just for a single plot. Grid and column layouts. If we want to have more than one plot or widget at the same time, the simplest arrangement to have is to have them in columns, one above each other, or in rows, or next to each other. Then there's a more complicated option called layout, which gives us more power, more control over more complicated arrangements. Hence, we'll start off with the simple ones. Column is a vertical layout. Of course, row is a horizontal layout. We give them multiple plots as their argument. So here I have my first plot, P1, my second plot, and I'm going to combine them using this line here. So I've got a column, now I'm passing it a list of the two figures, and I show that together, and hey presto, we have a column of our two plots. If we then try as a row, which you're all welcome to do, so I'll uncomment the row line, comment out the column line, of course they go side by side. No great surprise. We can put any number of plots we want in the same row or the same column. Layouts themselves can use sizing modes, so the fixed mode, the stretch mode, the scale mode. And remember, I described those as being the using of the space that's provided by the parent. That's where these columns and rows also come in. So we could specify the stretch mode of a column and also the individual plots within a column. So if we wanted to get two figures on top of each other, filling the entire width of the browser, then the column itself needs to have a stretch mode of stretch width, sorry, and the individual figures also need to have the same. As always, that sounds really complicated in my head, but the example is much clearer. So P1, one figure, P2, second figure, column. This time, the column, we've specified the sizing mode is stretch width, so the overall column will fill the whole width, and the individual horizontal sizing modes of the two figures. The top one is stretch width, so that's going to fill whatever space the layout, the column gives it, which is the whole width again, whereas P2, sizing mode, horizontal is scale width, so that will also occupy all of the width, but it will give us proportionate, keeping the aspect ratio the same, give us proportionate height. We have to look at that to see how it works. And as we get smaller, therefore, both plots get narrower. We never get a scroll bar, horizontal scroll bar appearing. But because the top one is stretch width, then it keeps its original height, but the bottom one is scale width, then the height is also reduced proportionately as the width is reduced. There we go. That was, same applies, of course, for rows. As for columns. Grid layout. We can have more complicated layouts using the layout, here we go, the layout object here. And here we can pass it one or more rows, and each row contains one or more columns. So you normally end up passing it like a nested list structure, so two levels of lists. So this example we have three plots, P1, P2, and P3. And we're going to give it a layout which has one row composed of P1 and P2 side by side, and then a second row which is just P3 on its own. If I run that example, there you go. Two plots side by side in the top row, second row on its own. Of course, the examples here are quite simple. You can build much more complicated arrangements by having many more rows within columns, within layouts, and so on, if you're so interested. And if there's one particular plot you want to keep fixed width, you can, and then other ones could be scale width or whatever to compensate. It's up to you. Tabs. Another alternative, if there isn't really room for multiple plots side by side or above each other, you can have tabs. They're essentially one behind the other, selected via a tab at the top. An example with two figures, P1 of circles, P2 of lines. And the code required is each plot is contained within what's called a tab panel, so a panel within a tab. Tab 2, the second tab panel containing the second figure, and we pass them both as the tabs option of the tabs object here. So here, if you like, the tabs is equivalent to the rows or columns of previous examples. Have a look at that. So we've got two plots. One is hidden from us. By clicking on the tab, switch to that. You would tend to use this then, for plots that don't really fit on the page at the same time, but it's also quite useful for having some, if you like, effectively pre-rendered a second plot that you know people are going to be interested in. It's sort of hidden from them, and we can quickly allow them to access that rather than, say, removing a whole plot, bringing a new one in, or having large amounts of space used up. As always, we can put different options for fixed width or stretch width, again, just as we have done before. That's I don't know actually. Probably not.
So what happens if you download the plot? Do you like have that same function?
If you download a plot, well, I guess it depends exactly what you're doing via downloading plot. However, in a couple of notebooks' time, we've got the various options for different ways of storing or saving, so hopefully that question will be answered then. Any further questions about this before I move on? Right. Notebook 11, widgets and interactivity. Now this for me is when it starts to get quite interesting. In the olden days, i.e. 20 years ago, it was fine to produce a scientific plot that was static, fine, pretty pictures, whatever, great. Nowadays it really needs to have to be interactive. We want to say display too much. If too much data is displayed, we want to be able to drill in or select or modify it in some way in an easy manner. And this is really what the core of Bokeh is for us. It allows us easy mechanism to have interactive plots, not static plots. So you'll see our tagline, we would advertise ourselves. We'll always have the word interactivity somewhere in the title. And here we've got a few examples, starting off quite simple, getting a bit more complicated. The first two examples are OpenURL and interactive legends. These are there's one or two lines of code to give us some limited but quite commonly accessible interactivity. OpenURL. Here we want the functionality that allows us to click on a bar or a circle in a plot, and it will open a new tab in your browser and take you to a web page of interest. So you specify the web page you wish to go to. It would vary typically by whichever circle you've clicked on or whichever bar that you've clicked on. We have an example data set here. So this is a number of countries with population figures, and we have a URL taking us to the Wikipedia page for that particular country. So just some test data. We create a bar chart with that, and we want to be able to click on the bar for China, and that takes us to the Wikipedia page for China. Let's just run that example and show that it works before we explain it. So there we've got our 5 countries. Let's click on, say, USA. I do that, and hopefully, yeah, it opens me a web browser tab, taking me to the United States. Back to the code. So the first half of the code is the same as we've been dealing with earlier in the day. We've got a single figure. We've got V-bars. It's a standard sort of histogram using V-bar. The new part is down here. So we've got in the toolbar here, we've got a tap tool, which we've added using tools equals tap. Normally you don't get a tap tool by default. We have to specifically request it. And then we want to tell it what to do when somebody taps on something. And the standard mechanism here, this is a fairly verbose way to explain the details of what we're doing. The idea is we have a tap tool, which is we have created up here. We grab hold of that using this slightly bizarre syntax, but select is a word used a lot in CSS and HTML to select particular items in the page. So we've got multiple things, we want to select them. Here we're selecting something by type. So we've got a tap tool created for us. We want to grab that tap tool and modify it in some way. The modification is to add a callback, which is an open URL, and we're going to send it to a particular URL. Now that is, as Bryan talked about, that's one of our sort of callback variables. So it's an @ symbol, so that means it is a column in the column data source that we have passed. So we're drawing 5 bars, one for each country. Each of them has a different URL from the column data source. There's actually an alternative way we could do this, because this is maybe a little verbose if we prefer tighter code. Instead of saying tools equals tap, we could do something like tools equals tap tool, whatever. And in fact, we could do the callback. It could be done in there. It would be like a 1-liner instead of the 3 lines. But if you're interested, look it up in the help. That was OpenURL. Oh yeah, okay, we haven't finished yet. So that was our test data. Here we've got one of our use of our real data set, which is the airline figures. So we've got our real data there. And for each carrier, we have a unique carrier abbreviation of 2 letters. And what we want to do is if we click on a particular bar chart, a particular bar for a specific carrier, we want it to go to a web page related to that carrier. And this doesn't quite fit on the page. It's quite complicated. Let's run that. Check it works. So we've got our 10 carriers. Let's click on Alaska Airlines and check it works. It opens a new tab. According to what we've told it to do. And it's filled out search string, and in fact has found Alaskan Airlines as the first one for that. So perhaps a more realistic use of OpenURL for some real data.
Does it always open a new tab, or is there somewhere in there where you can make it open a current tab?
It always opens a new tab for this setup. So we're running in a notebook, and we don't want the notebook to be replaced because that you're going to throw away potentially a lot of half of your calculations that you've just done, so it'll always open a new tab. But of course, as we come to the alternative ways of running things, then the concept of a tab doesn't necessarily exist, so it would replace its contents. We'll get to that. The code for this then, it's similar to before, of course. We've got a bunch of tooltips, which we saw when we hovered over. That should become familiar. That should be familiar by now. We've got the standard figure creation. We've got the V-bar. We created the tap tool in the tools keyword argument of the figure. And then we plug that into our callback, which is the open URL for a particular URL. And we substitute the unique carrier column from the CDS into the URL for the appropriate bar that we click on. And what information available. Second item here, muting and hiding glyphs. This is a simple use of legends to make things, glyphs appear or disappear or become muted to emphasize different ones. This is based on a keyword argument of the legends, which is click policy. Normally, this is turned off. We don't do anything by default, but we can have it set to mute to make to keep the glyphs visible but smaller alpha value, so they're more transparent, they're less visually impactful. Or we can set it to hide, in which case those glyphs will disappear completely. Effectively, their alpha is 0. This example uses some of the sample data that we ship with Bokeh. So we'd normally have to run this cell. Of course, I've already run it earlier today to check it worked, so that's very quick. It might take you a few seconds to download the data set. And then we'll look at the example. Here we are drawing 4 lines, one for each of 4 different stock prices. Each has a different color. We've got a legend on the left because we have used legend label here. So that's the name of each of the stocks. And we have a click policy on the legend of hide. So if I now click on Microsoft, it disappears from the plot. It still appears in the legend, so we can click it to bring it back. Hence we can turn different things off or back on again. As an exercise, if we change click policy from hide to mute, rerun it, now it won't. The corresponding line won't disappear, but it's just displayed with a lower alpha, so it's less visually impactful. Of course, you can have full control over the alpha value that's used for that. In fact, you can do some very strange things, like for a muted glyph, you might decide I don't even want it solid line, I want it to be dashed line, or even I don't even want it to be a line, I want it to be something else. There's lots of power available to you, but by default here, all we would do is set a lower alpha value. That's useful for 90% of use cases. That was our sort of test example. Here we've got a real example based on our data set. Now this is quite a big plot. There's lots of data being sent to the browser here. So some of you who are running on the Quansight and the Bari system might find you're getting an error code for one of this. Just rerun it if necessary. here we have quite a large amount of data displayed. There are 3 different categories: passengers, freight, and mail. And we've set up a click policy of hide, because if this is too busy, I can't see the passengers. They're all hidden they're obscured by the freight and the mail. If I turn off the freight and the mail by clicking on it, we can see just the passenger data. Bring it back. I could set that to be mute, couldn't I? Sorry. Sorry, it was already mute, wasn't it? Set it to hide. No, it was already hide. I'm sorry. I'm going around in circles. Mute. Take a few seconds to load again, and now if we turn off freight, it's still there, but a bit faint. In fact, it's probably not faint enough in this scenario. I'd probably want to have an even lower alpha value for the muted situation.
Is there a way to have it, like, if you click freight, to have only the freight show up so it can use the other values?
I think you would have to write some custom, yes, because there's always a way to do anything. We'd have to write some custom JS to do that, which we'll get to shortly. It wouldn't be very complicated, custom JS. Oh, here we are. In fact, custom interactions, widgets, and JavaScript callbacks. First of all, we'll talk a little bit about widgets, which are in 2 categories: controls, i.e. things that we can give some input. So like a slider, you can drag up and down a button you can press, a text box where you can put some text in, so giving information to your application. And also there would be like output widgets, which would be divs, like HTML div or paragraphs, where you can put the contents of in, and that would be just text or HTML, but of course you can dynamically change the contents of that. So up until now, figures are all graphically based data visualization, but we can also have textual output in, say, divs, and we can have these controls, these other forms of widget. We'll quickly show you some examples of those before we look at some decent custom callbacks. So here's a simple widget, which is a checkbox button group of 3 separate buttons, and each button is either on or off. Doesn't look very exciting, but a few lines of code, we've got those buttons. We would use those in conjunction with our plots to control some aspect, which we'll get to. Slightly more exciting is a slider. So a slider we would specify, it's normally a numeric slider, or it could be a date slider, like a date time slider. You'd specify where it starts, where it ends, where the initial value is, and the step, what are the increments it can move. So here we have a slider from 0 to 10, start off at 1, steps of 0.1, and we can drag it up and down, and it tells us where we're at. So we could use this as a mechanism of controlling some of the visual aspect of our plot. We get an example of one of our output rather than input widgets. We've got here a div. Slightly less interesting, but still useful. And for some reason, we've chosen a fairly dark green to show that you can. I wouldn't suggest you normally do that. But here we are we have passed in some standard HTML paragraphs, headings, so that will be rendered by the browser using normal CSS and HTML rules. In this case, actually, we've also got a little bit of LaTeX. So we have an equation at the bottom down here, and we'll have a shorter side to that in a minute. So those are a few examples of widgets. How can we deal with those? Well, fortunately, they work in exactly the same way as figures do for combining in rows, columns, layouts. So now it all sort of comes together a bit more nicely. Here we have a combination of 2 plots. There's a div above it giving us some textual output. There we go. So the div is in the first row. The 2 plots are in the second row. So where we've put into layouts before just plots, we can now put in divs, sliders, buttons. The sliders, for example, could have a stretch width to fill all the available space, or they could have a fixed width, and so on. The same rules apply. Callbacks. Now we want to do something with those. We've got a slider, we've dragged it backward and forward, didn't do very much. Let's hook it up to something so it changes some of the visual representation of the plot. There are 2 really simple ways of doing this, and then a more complicated, highly configurable, more powerful way of doing it. The 2 simple ones are JS link and set value. Now, JS Link allows us to directly attach, say, a slider, which has a numerical value, to the property of some, well, in fact, of any Bokeh model, which basically means anything, pretty much anything in Bokeh. So we could control, using a slider, the size of circle glyphs, or the line width, or the alpha value, or whatever. The example here, I've got a column with the slider and then the plot below, and if I have the slider attached to the size of the circle glyphs, so if I drag this up and down, we change the size of the circles. In a relatively small amount of code. So we've got the plot, the figure created as normal. We create the circle glyphs. This time we have to store what is generated, the circles. We have to store a reference to the object because we're going to do something else with it. We have a slider, and we hook the two together using this JS link. So this is really saying I want the value of the slider to be automatically connected to the size of my circle glyph. So you can almost say it as a sentence. And that's really only one line of code to hook those two things together. There's quite a lot of clever things happening in the background for that to work. There's a full explanation there. It's probably better than mine, but I won't go through that in detail. If you want to understand the details of what's going on, then work that through in your own time. That was JS Link. Another simple example is set value. This is like the slider is a continuous control, and we want that to always update the target whenever it's moved. Set value is an event-driven sort of single shot when we do a particular activity. So the classic example is pressing a button. So we press a button, we want it to change the property of some other model. Let's look at the example. Here we have relatively simple output. We just got one colored button down here. We created the button. We stored a reference to the button. We created a set value object. So it's a bit like the JS link in terms of its contents. We said for the button, when we use this set value, we're going to set the button label to be the text bar. And we connect that action with the button click using a separate line here. If I press the button, it changes to bar. Of course, we could do much more complicated things than that. So those are two simple ways of us grabbing changes. Sorry, go on.
So for the set value, is there a way to add another value? So instead of just changing to bar, if you click it, then it's yellow warning, and then a third click would be red stop.
Not using set value, no, but we'd use a slightly more complicated JavaScript callback that we're about to get to. Yeah, so probably you want it to. Oh, Brian. Yep.
I was going to say, not presently. When set value was added, there was some discussions about some enhancements that I think it was probably straightforward to add. But maybe sometime in the near future, that would be possible.
And probably another useful feature would be like a toggle feature almost. Yeah. The second time I press it, it does nothing because it's already set. Maybe I want it to toggle back. So I guess there could be like a list of arguments passed to it, and it goes to them in order or whatever. Yeah. But yeah, not today. Again, there's a full explanation of the details of what are going on there, but I won't go into that in too much detail because I'd rather talk to you about my preferred solution, which are custom callbacks. So here we are talking about custom JS. Here we create some JavaScript code that is sent to the browser and allows us to do pretty much anything we want because we can give that callback information about the data displayed or the visual properties, sizes of stuff, and we can tell it to change based on different activities. We have a very simple example here. I've got a button. You scroll back up. And when I click on this button, it opens an alert, which is basically a little dialog box at the top with some text in. Not very interesting, but we've caused that event to happen. So the way we do that is similar to the previous example. We had a button, then we attached, we created an object that encapsulated what we wanted to do when the button was pressed, and we hooked up the action to the button when it was told it when you were clicked, this is what I want you to call. Same sort of arrangement. We have a button. We have the custom JS code, and we are literally passing in a keyword argument which is valid JavaScript code. So of course you need to know a small amount of JavaScript to do this, but sort of stuff you would learn on day one of a JavaScript course. You don't have to be an expert in JavaScript to do this. And the third line, we hook the two together. When you click on the button, please call this action, which is the custom JavaScript callback. That was a bit simple. Let's do a more complicated example down here. In fact, I'm just going to run it and show you the results. So here we have a slider and we have a single plot underneath. And if I move the slider, it changes the mathematics of the equation, of the line of the equation that's displayed. So we're doing y equals x to this power that we've selected here. How have we done that? Well, we've got a slider as before. We've told it to on any change in the value of the slider, can you call my callback? And the callback is defined as a custom JS. We have the code that we had in the previous example, so we give it some JavaScript of our choice. This one's a bit more complicated. We also can tell it to pass in arguments. So in this case, we're saying this callback needs to know what the source is. It needs to know the column data source because it's going to modify it. So we tell it that the source is required. And our code firstly grabs the value of the slider, which is, so whenever that change, this is called, and then we get the value of the value. Yeah. And there's a note there that tells you that the model that triggered the callback is accessible as to this variable. So because we attach this as to a button, that's the button.value. We grab the X data from the column data source, and then we create new Y data, which is X to the power of F, using standard JavaScript functions. Okay, we're using a lambda function there, which maybe isn't ideal for JavaScript new people, but yeah. And then we simply pass the new X and Y to the source.data. So we are getting the column data source. We found the value of the power, and then we get the X values from the column data source, calculate new Y, and set them back in there. And it all sort of works. Actually, what's going on is quite complicated here. Because remember, we're programming this in Python. We've given it a string of JavaScript code, and we've told it needs to know the column data source. Of course, the column data source is defined in our Python script, but it all magically hooks up on the JavaScript side so that the correct column data source is passed in as a JavaScript data structure which can be varied. So this is really, in my mind, this is one of the key reasons for people using Bokeh. It's the synchronization between programming Python and what appears on the screen in JavaScript. Lots of those things like magically synchronize, and we need that to work for these callbacks to make a difference. Worth spending some time mastering these custom JS because you can do some very, very complicated things, of course. Pretty much anything. It does force you to learn some JavaScript, though. We've got a link to the appropriate section in the user guide. And the final part here of this notebook, that, of course, was our test example. This is one using our aeroplane data set. It's quite big. Let's run that. This will appear in our final dashboard. And we have a slider. And we've hooked up our slider, so whenever we move it, it calls our custom JS callback. And that simply changes the number of airlines that are displayed. But it's quite neat. How does that work? Well, this time, so all the work is happening in our custom JS object. The code itself, just 2 lines, that is in fact varying, that's changing properties of the plot itself. Previous example, we changed properties of the column data source, the data contained therein. Here we're changing properties of the plot, and hence we must pass in the plot in our args, and we have to pass in the carriers because it needs to know something about the names of the carriers. So this example is some sort of more real-life example. We're accessing plot attributes as well as data attributes from the previous example. Right, that's the end of the interactivity page. I'll quickly stop for questions and have a sip. Yeah, we're getting to that.
Okay.
Yeah.
I don't know Java.
Yeah. Now, there were 3 little appendices to our tutorial, which we don't normally talk about, but we've added here for more interest to those of a scientific dispositions. So one example in that page, we had some LaTeX equations. So I have a very brief, if you like, side look at LaTeX in Bokeh, relatively recently added. I'm going to run the whole lot in one go. Here's a sort of real-life example. So I'm plotting some Bessel equations. Where am I using LaTeX? The title's got a fairly complicated equation. I've got some on the y-axis label, the x-axis label. I've got some separate labels with a capital L on the plot. How are those set up? Well, if you're used to using LaTeX, then you'll be familiar with the double dollar signs as start and end delimiters. We have to be a little bit careful. So we can pass in a string which contains the dollar symbols to specify LaTeX content. We have to be careful and use an R in front. This needs to be a raw string, because otherwise the backslashes, which are very common in LaTeX expressions, are not escaped correctly. So it will just come out as garbage. So we've got, here we go, the title itself is LaTeX. There's the X and Y axis labels, and then we've got ones down. I've dynamically created some strings down here to add the label objects. So summary, use of standard LaTeX delimiters, other options available, raw Python strings. Ah, yes, right, div and paragraph accept LaTeX for just part of their content, so you can have, normal words, bit of LaTeX, normal words, fine. For other uses of LaTeX in Bokeh as of today, you have to have the whole item to be specified as LaTeX. So a label, you can't have a few words and a bit of LaTeX, and a few words, the whole thing has to be LaTeX. That will be relaxed soon. In fact, we've got a PR in the queue to deal with, which we might get to tomorrow. Here is an example of all the places we currently support having LaTeX. Let me make that a bit bigger again. I forgot to do that. So figure titles, axis labels, tick labels. We can have arbitrary labels wherever we want in data units. We've got color bar title. There's a slider, div, and paragraph. More will appear. Right, back to where we should be. So next up, we are on demo dashboard. Right, throughout the tutorial so far, we've shown you examples of the sort of things we can do with Bokeh. Then we've applied it to our aeroplane, our flights data set. Here we're creating the total dashboard, which is the summation of all of that work on the flights data set. Now I'm going to run this as a single entity in one go, and because this could take a while to run. As you can see, this is quite a large page. I'm not going to go through every line of this, but eventually it will update the final plot, which is the whole dashboard. And here it is. This is like the target of our tutorial, bringing everything together in one big, complicated layout with a number of plots. We've got a div across the top. We've got a plot here where we've got that's our JavaScript callback, controlling the number of airlines displayed. We have a plot here where we've got some hover tooltips, and we can mute certain lines via the legend. Of course, all of this is, everything's always, zoomable, panable. We can reset that. We have a plot with large amounts of data. And again, we can mute or hide. This is hide, isn't it? Different sets of markers. We've got our, oh, sorry, that's not right. We've got the map plot with some tooltips which contain a number of bits of information. We've got our donut chart with multiple tabs. So we've tried to fashion an example which is reasonable, but to demonstrate lots of the bits of functionality that we've covered in the tutorial. Now, I recommend going through all of this line by line at some point, but I'm not going to do it with you today, because even I will fall asleep going through it too much. But essentially, this is a line by line. Even if you hadn't read any of the previous 11 notebooks, you could follow this through line by line, how we add add things incrementally. So for each section, let's ignore the header, that's very simple. For each section, for each figure in the final layout, we've got accessing the data, the imports, specifying some configuration values, then there'll be the plot formation, and so on and so forth. So we do it line by line, or a few lines together in individual blocks. There's some explanation in words about what we're doing, why we're doing it. That brings it all together eventually with the show, i.e. how to display that on the screen, that particular example. And then we also bring the whole lot together. So this is for a single figure only. We've got the code for that figure, and it's displayed again here. So that's repeated for the 5 or 6 times for each of the individual figures. So go through that if you're interested and have the time at some point, and that will be a good summary, if you like, to revise everything else we've covered in the day so far. I think at this point, oh yes, I was going to use the excuse to go to the WebGL appendix. Now this plot here that's quite big, the data for this plot, that's a large amount of data, and we're using WebGL to visualize it. Let me talk a bit about WebGL. Appendix A. And let me kickstart that. Whilst I'm talking. Right, by default, Bokeh renders in a browser using what's called HTML canvas. It's an API that allows us to draw circles, lines, specify colors, and so on, and it's very sort of human-centric. It's quite easy to think of drawing a line. It's like, I have a pen, I want my pen to be red. I put the pen down here, I draw to there. It's quite easy to understand for humans, so it's great to use, and it's quite fast, but that's not really how computers work, so for very, very large data sets, that doesn't scale very, very well. An alternative is WebGL. So that's an API that we can use from a browser that can take advantage of graphics acceleration. So if your laptop has, say, a graphics card in it, because it's a games machine really, but you've pretended it's for work, then you'll have lots more performance available, and we can take advantage of that by using WebGL. Even this Mac here doesn't have a dedicated graphics processor. It's sort of on chip. It's half and half dedicated, can give us bigger performance. Let me show you the sort of thing it can do. So here I have a data set which is, there we go, 5 million X and Y values, randomly generated. I'm going to create a hex bin, which is a type of plot, it's a histogram really, but with hexagonal primitives rather than rectangular ones. And I have created, somewhat arbitrarily, 142,000 hexagons to display on my plot, and each of those is coloured individually according to how many of the random values are within that particular hexagon. Taken advantage of this handy function hexbin to do all the calculations to work out all the hexes and stuff. Then I want to display. So this is 2 different renderings of the same data set. On the left I have HTML canvas, on the right I have WebGL. They're supposed to look the same. WebGL is written to look similar to Canvas. In this case, actually, Canvas has some white artifacts which aren't ideal, and the WebGL is better. I love that because I wrote the WebGL code, not the Canvas code. Otherwise, I would have changed the example to show it off in a better light. Right, I'm trying to prove that the performance is better, so let's pan the canvas. So there, I'm panning in real time. That's what, 2 or 3 frames a second maybe. It's a little bit slow. If I do that with WebGL, thank you. Can we do that again? Oh no, right. So yeah, it's quite well. And so this isn't even using a decent graphics card on on your games machines. This could be very well if there's such a. Yeah. Yeah. So we'll do the wheel zoom on the left canvas. I mean, it's probably usable, but you're not going to impress people with it. And eventually we get in and we see individual hexagons. Hey presto. On the right. Did I hear wow again? I think I did. And I can make it worse / better if I select, just as always, you unselect the tool, don't you? If I select 1/4 of the data set, Again, I turned it off. Do that every time. 3 times in a row now. Here we go. There we go. I selected 1/4 of it, and because I know how Bokeh works, it's basically it sort of has to go through the rendering twice. It has to render the muted glyphs once, and then the non-muted ones a second time, so it's double the amount of data that's being passed around. If I now do my wheel zoom, there we go. Turn it on there. I don't really think that's acceptable on the left, but on the right, there's a little bit of a lag, but it's pretty nice. WebGL. It's a new thing 10 years ago. We're catching up. So I showed you some examples. How much faster? Well, we cannot generalize. It depends on the hardware you have available. Some computers have dedicated hardware, could be really, really super fast. Others have like on-chip graphics processing, which can be fast-ish. Others don't have any at all. Could actually be slower. Always try and buy a computer with a graphics card. How do you enable it? Well, it's actually really simple. The only difference between those two plots is this output backend keyword argument, which is passed to the figure. Normally it's canvas. Here it's just WebGL. When we do that, what we're actually doing is saying, I would like to use WebGL if you have it available. Now, not all glyphs have a WebGL implementation. All have a canvas implementation. Some have WebGL. So by asking, I would like you to use WebGL, if you have WebGL-enabled hardware, and that glyph has code written to support WebGL, then it will use WebGL. Otherwise, it will fall back to canvas. So if you ask for WebGL, and what you're looking at contains glyphs that aren't really supported, it doesn't matter. They'll just be rendered more slowly using canvas. You still get an output. And there's a link, I guess, there's a link there to the page that shows you what's currently supported. That's being added to all the time. We've got multi-lines were added 2 weeks ago. Not in a release yet. We're trying to constantly add new features. That was, okay, so then we're back to 13. So we've got 2 relatively short notebooks to go and 1 more appendix, and the end is close. Exporting and embedding. Excuse me one moment. We have chosen to run all of our tutorial using Jupyter Notebooks, so in browser this particular way because it's quite a nice experience. There are many, many other ways we can do things. The first one is standalone HTML files. Now, what happens really is we tend to write, of course, we write some Python code, and then we want to visualize it in a browser, and we've talked quite a bit about how JavaScript is involved there. Really what happens is I keep calling it magic, something that people don't need to understand. The Python code is understood enough, the data is parceled up in an appropriate way to send to the browser to be displayed. Now, in Jupyter Notebooks, that happens on a cell-by-cell basis, so we can have a cell of Python code, and then we can have a cell containing 1 or more figures, which is the output running the JavaScript. But we can have standalone HTML files. So we could have a single script, Python, which starts with your imports, creates the figure, does the show, whatever, as like a standalone thing, and we can run that to create a HTML file without ever using, at this point, a browser or any sort of interactivity in that particular way. And that HTML file contains the resulting figures. You can still interact with it. You can zoom, you can pan. It's all like contained within the HTML file, and you can pass that around to your friends or whatever, and they can render that in a browser of their choice. So it's quite a strange workflow for people. How do we do that? Well, here, of course, this is slightly silly because we are running a standalone HTML generator within Jupyter Notebooks because that's what the tutorial is in, but we could do this standalone. So there's an extra sort of levels that we have to jump through to get this to work here. But this works. Have I done any imports? No, here we go. Right, let's just go for it. So the key thing is, before we had output notebook saying, can you put the output in the notebook? Thank you very much, on this cell-by-cell basis. Now we're saying, can you put the output in a file, please? Give it the file name, HTML file. We can give it a title that it puts at the top. And if I run that, it's not very exciting. We don't see any output because, of course, it's written to a HTML file. I could open it to show you it. In fact, that's what we do further down. In fact, I can just open it here, can't I? If I copy that, I have too many tabs open. That's the plot generated, so that's now running. It's running? Yes, it's running. It's a HTML file containing JavaScript. It's running. We can still zoom that. I could email that to somebody. They can open it in their browser like this. They can still do the zooming and the panning and the interactivity. One important thing for advanced users, so we specified a file name and a title. This mode here is important. For the generated JavaScript code to be runnable, we need a compiled version of Bokeh.js, the JavaScript side of the Bokeh library. By default, that's obtained from something called CDN, a content delivery network. So that's like repositories on the web where such packages are stored and they are replicated around the world for quick access, and they're generally cached locally or whatever. You sort of don't have to worry about that most of the time, but by default, when you run that HTML file, you would need internet access because it has to get the Bokeh.js CDN downloaded to run for you. Well, it downloads it the first time, then it caches it. Next time you will be fine. But there are other options that you can, in fact, using inline, you can embed the whole of Bokeh.js within that HTML file. Then it's definitely like a standalone piece of code you can take on a, I was going to say floppy disk. What are they? You could pass on a USB pen, yeah, showing my age, and give to other people. And they could run that on a computer that has never been connected to the internet because it contains all the Bokeh.js required. There are still such computers in existence, I guess, in whatever, defense and so on. So standalone HTML. And we controlled it from within the browser by our choice of output notebook or output file. If for some reason your workflow requires you to have some output in the browser and then some in separate files, then we can call reset output here, but probably just as easy is to fall back to the original setting. So output notebook, do some stuff in notebook, output file, do it in file, and then output notebook again to go back to the notebook stuff. Embedding Bokeh documents. In fact, this tells us a little bit more about how things work. What happens when you output file, you're really generating two things. You're generating some pure HTML, which is like the div, which is the container for the code that's going to run, and script, which is the JavaScript equivalent of the figures and data that you've asked it to display. If I call this, so I've got a really, really simple example, just a figure and a couple of circles. If instead of calling show, I've called components, then we get the two items separately. So script is JavaScript, and there's some words in there you'll recognize, you know, boxing tool, and we've got CDS and attributes and so on. That sort of makes sense. So that is JavaScript code in a script tag, and we've got a div, which is not very exciting, but it's the container that the plot will grab. So somewhere in the script, it will ask for what's this. It will have this ID, and it will basically pump the contents of that are visualized into that div for you. Why would you want to do this? Well, if you want to use Bokeh, but you don't want to tell people you're using it, for example, you can use this script and div, and you could put it in a separate web page. So you might have a complicated web page already set up, doing lots of really interesting things, and you want a Bokeh plot towards the end. Then you could embed the script and the div into that plot, and it all works out with your workflow. Up until now, everything else we've done, we've basically been doing just Bokeh because that's all we care about. Why would you do anything else? But if you need to, that's an option available. So you can see that there are multiple ways. We haven't even covered them all yet. There are multiple ways of using Bokeh to generate output in a browser, depending upon your workflow. Export. We can export to PNG and SVG if we wish. It's a little bit silly using Bokeh to generate static PNGs. We really want people to use it for interactivity, but of course we support that. Now, one thing you will have to do if you want to run this example is we need to have Selenium installed, which is a package which allows us to run a browser, but without the browser having to appear on the screen, like a headless mode browser allows us to control that. And we haven't included that by default into the conda environment that you're running. So to install that, if you want to run this example yourselves, you either have to uncomment the conda line and run that like it is. I'm not going to do that. It doesn't work on my M1 Mac because some packages don't exist yet or never will. So I can do a pip install Selenium on that, and the exclamation mark at the beginning of the cell tells it to run command line code rather than Python code. So pip install Selenium, it should say it's already there. So that's like our headless mode driver sort of thing. And now a simple example, we've got a figure containing a circle, and we're going to export PNG, give it a file name, run that. It will take more seconds than normal. Oh, that's good. So we've exported the PNG file, and I'm going to use IPython display to grab that file and pop it back on the screen. Sure enough, it looks the same as it normally would. That's a PNG. We can do the same with an SVG. So SVG, scalable vector graphics, so that will scale better if we're going to look at it at different zoom levels. I didn't so in the WebGL appendix, we had a choice of Canvas and WebGL. There's also an SVG backend if you want to render in the browser using SVG rather than Canvas or WebGL. Certain circumstances, it would be considered better. Yeah, I'll say no more. So there's the SVG. Looks the same. We've gone to quite a lot of effort to try and make it look the same. You don't want the output to be different if you've asked for SVG compared to PNG. Okay, any questions about any of that? So we're down to our last two notebooks. We've got one more appendix and then the final notebook. So the appendix, let me delete some of these. Let me close some of these. Appendix, contour plots. Let's run that in one go. A relatively recent addition to Bokeh is contour plots. Here we've got an example. It's a contour plot, yeah. How does it differ from other libraries? Well, we've got a single function call to generate both the contour lines and the filled polygons between the lines. Quite often, if you were using Matplotlib, for example, you'd be doing a contour F call for the filled polygons and a contour call for like black lines between them. Here it does the whole thing in one go for you. So we pass in the X, Y, and Z. These are 2D arrays, it's gridded data, levels to calculate the contour levels at, and some visual properties. Here, if you specify a fill color, you'll get filled contours calculated. If you give a fill color of none, it won't bother calculating and rendering any filled polygons for you. Same with line. So for example, if I make fill color none, rerun it, it doesn't bother doing any calculations of the fill. And we can do, as is always the case, we can start adding other properties. So for example, I can do a hatch pattern. And in fact, we could do more complicated combination. If you wanted it only to be hatched for values greater than 1 or greater than 0 or whatever, and differently for less than, then we can control that by giving it some different vector properties, but then we're getting into too much detail. Anyway, there's a link at the bottom in the topics guide for contour plots, one of my pet subjects, so we'll be adding things, I personally will be adding things to that over the next coming 6 months to make it a little bit more polished. Final notebook. The end is in sight. So a small amount to say, but some of this is quite important. We talked about, we've been running Bokeh in a notebook. We talked about standalone HTML, embedding, right, Bokeh server. This is quite an important thing. So everything we've done up until now, we're basically running a bit of Python code. So it starts Python interpreter, runs some Python code, which generates something that's going to go to the browser. There's sort of JavaScript, script and div stuff. And then Python stops. It's like a fire and forget. Run it once, stop it. With the Bokeh server, we would start a Python process and keep it running whilst we're interacting with it. So this is the question earlier about, can we have a Python callback? We've had JavaScript callbacks for lots of things. We can have Python callbacks for all of those same things. So it magically calls the Python callback in the Python code rather than JavaScript one. So then you could use Python syntax for your callbacks. You can get data via Python rather than running within the browser. The example we'll show you here, we've got a demo site which is at demo.bokeh.org, so that's running on some AWS instance somewhere in the world, don't know where. So we've got Python processes constantly available for that, and we're accessing this remotely. So now I've got some sliders here. If I drag the slider here, so this is identifying that we've moved the slider. It encapsulates that in some sort of message. It's sending that from my browser to the Bokeh server somewhere in the world. The callback is there. It makes a change. It sends the results back to me. We won't go too much into the code there, but if you're a Python person, don't really want to learn any JavaScript, and that's a completely reasonable decision, then Bokeh Serve is the way to go. It would also be advantageous if you were, say, doing a company or university set of websites or whatever. You could have one server instance set up, or perhaps it might fire up new instances on demand based on workload, and then you can have lots of people to access the same code quite easily, rather than giving them all a version of your code. You're just serving it from one local place, and people access it via the URL. Other options: Bokeh.js as a standalone library. So Bokeh itself is the whole beast. Probably only 10–15% of Bokeh is Python. Most of it is JavaScript, which is the Bokeh.js library itself. You can use Bokeh.js without the Python bits, if you wish. And there's a link in the user guide about how to do that. We are saying this is considered experimental, by which we mean you're welcome to use it if you want, but when it goes wrong, we've told you it's experimental. We don't expect it to be fully robust, because it's basically changing all of the time. So it would be fine if you if you pin to a certain version of Bokeh.js, that would be fine. But we're expecting to hone this and improve it and come up with some definite decisions about that API, so that Bokeh.js exists as a standalone library on the JavaScript side, without having to be hooked into Python necessarily. There are also examples of extensions to Bokeh. We've got our sort of cunning system whereby we can have, say, callbacks that change properties of different models. There's like a lot of infrastructure. If you wanted to extend that yourself, you would have to define model classes inherited in a certain way from our particular model classes. So you'd have to do a Bokeh extension for that to fully work. We have some examples about how you would do that. Essentially, you'd have to write some Python and some JavaScript code, wrap it up in the right way to hook into our code. That's all fine. That's not experimental. Finally, some high-level tools. Bokeh, we'll say Bokeh is fairly low level. You can do anything you want, but some of our example code is quite verbose to allow you to be able to change all of those parameters, the widths, the colors, the layouts, the stretch. You end up having to write potentially quite a lot of code. There are other libraries built on top of Bokeh which won't allow you to access 100% of what we do, but they will make, if you like, sensible decisions for you to allow you to only write a smaller amount of code, is the sort of argument. This is, in fact, what I do in my day job. So the three we'd mentioned are Panel, Holoviz, and hvplot. They're all grouped together called Holoviz, and in fact there was a tutorial this morning about Holoviz, which I think a third of you were in or something, perhaps. So Panel is a dashboarding application, again, Python and JavaScript. It allows you to fairly easily connect these. Well, if you like, the callback system is much more powerful, if you like, the defaults than our explicit way of doing it within Bokeh. So you could build quite quickly dashboards that are interactive and have controls hooked up to visual properties, quite simply. There are lots of similar dashboarding libraries, I guess. Holoviz is separate to Panel, but built on top of our sort of data presentation, so our line glyphs, our scatter glyphs, but it encapsulates them in the concept of what the data is rather than what the rendered output is. So here we've got an example. It's just we're not actually running that, of course, because we haven't got this in our environment. So for example, we've got hv.points we've got some data that we want represented as points, and by calling it points, it has some concept of some like default behavior that makes sense for points, and it will give you that for free. So if that behavior is what you want, this could be quite a elegant solution for you. All the output is bokeh in these examples. And finally, hvplot is for people who like doing a lot of pandas or X-array. It allows us like a data-centric view of those data sets to allow them to be visualized quite simply. So for example, there is, if you have a pandas data frame and you import hvplot, you could say dataframe.hvplot.explore, and it gives you our data explorer, which allows you full access to all of the columns in some sort of sensible default way, so you can explore your data. Now, if the design decisions there make sense for you, then that's a really convenient, quick way to explore your data set. Finally, there are some links here. If you want to access any further information, you're welcome to do so, all in our documentation system. At this point, I believe we have reached the end. So I will say thank you very much for attending. We will hang around further so we can answer any questions. You're welcome to sit there and shout them out, or leave the room, or come and chat to us at the end, or send us Slack messages, whatever you want. Otherwise, thank you very much. And somebody has to be first to answer a question or leave. But, yeah. Can you take that while I have a...
Yeah, so a little bit of context here. So like I said, the Bokeh server is kind of a large topic unto itself, which is why we didn't really have it in this tutorial. But let me go ahead and just set some context here. Let me actually go to demo.bokeh.org. And you can see a bunch of Bokeh server applications that have been deployed and are running. So I just want to show you sort of what they look like in terms of like what's possible. And then we can link to the code and sort of look at that. Here's an example. So this example just plots 3 distributions, and you can make a selection. And what it actually does is it computes the histograms of the selected regions and the non-selected regions, and then updates those sort of histograms, the joint histograms on each axis, right? So and that happens. So there's Python code. There's actually running NumPy code to do that. Another example here on this demo page is, well, here's our famous slider example, right? And it's just, we can modify this slider. This is actually running Python code to, again, recompute the values of this sine curve based on the slider. And if we, change something for the title, it updates there as well. Maybe just one more quick example, and then we can look at some code. It's a good one. This is a nice one that's a reproduction of that Gapminder example, and it's got like an embedded video and stuff. And so you can scrub the slider here, and you can see that the data is updated based on that. And there's even a little play button that can set some periodic callbacks, that cause the famous Hans Rosling sort of animation to happen. So anyway, so what do these look like? So if we actually take a look at the code for instance, this slider one, all the code is linked on these examples from demo.bokeh.org. Here is what that looks like, right? So if I click on sliders.py here, so I can make this bigger. Is it plus? Will that work? That works. Okay, let's make that really big. Hopefully that's big. Let me know if it's not big enough. So it's very similar to what we've already done, right? We've got some data we create. We put it in a column data source. We create a plot here. We call line to plot the line. Here we add some widgets. We add 4 sliders and a text input. And now instead of JS on change, we use this on change function, and we just pass it a Python function. Similarly, we call, and this is update titles, right? So it takes the attribute name that was changed, the old value, the new value, or what are passed in. And so we say something like plot.title.txt equals the new value on the text widget. That gets executed anytime that the text widget gets a new value. Similarly, for the slider there's update data. Again, all these callbacks have the same signature. They get the attribute name that was changed, the old value, the new value. So every time that slider is scrubbed, it gets the new values for all of them, because it can access them. And then it computes a new X and Y values, and then it just sets source.data equals that data. And this is all in Python code. So we add that callback to all 4 sliders. And anytime those sliders are scrubbed, this function is run. It's important to know here the Bokeh server is kind of like a web server. Every single person that navigates to the Bokeh web server gets their own session with their own document. And these bisynchronous, these sort of bidirectional updates happen from their web browser to their session, right? So multiple people can connect to Bokeh, demo.bokeh.org and see things deployed. I will say, it's a little bit like you have to have the server running somewhere, and if you need to actually scale out to a larger audience, you'll need to do things like running it sort of behind Nginx or some load balancer. That's why it's a little bit of a larger topic, is because it can be very specialized to different use cases, right? It's very flexible, but there's oftentimes you need to come to discourse.bokeh.org and ask questions or things like that. But this is what the code looks like. And I will say this is actually kind of an exciting time because there are also folks who are working on making it possible to write this code with Python callbacks that actually uses things like either, PyScript, or what's the other one? WASM, but what's the name of that project? The PyData, yeah. There's folks working on that. So that you can write this code that has Python callbacks that just generates a web page that's not backed by a server that just runs in the browser, right? That's an exciting future. That's not here quite yet. Yeah. Yes, it is. So it's a little bit different. Let me go to one last thing here. I'm going to go to the docs page. Well, actually, I guess it's in the repo. So let me go to the repo. And if we go to our example, sorry, go ahead.
I was going to say, while you're doing that, so one observation from the Python code was the callback had all the Python objects we'd created in scope. Yeah. So with the JavaScript callback, we had to specify the args.
Explicit.
Pass in the column data source, pass in the plot, because we want to change the title. If you write your Python in standard Python way, then the CDS is in scope, the plot's in scope, so you can just start writing your code, and it's quite standard Python stuff.
Where, actually don't know. Actually, we've rearranged our examples recently too, sorry. We have a bunch of Bokeh server examples. One thing to mention, under the examples directory, server application, there's a bunch of examples there. I actually don't know. Here we go. It's under notebook, right? Yeah, notebook embed. So it is possible to embed these Bokeh server applications in notebooks. There's kind of a particular way you have to do it. And the reason for that is because, for better or for worse, notebooks allow sort of arbitrary, out-of-order execution. And some people love that, and it's really great. But for other things, it really makes it difficult to reason about your program state. And so when I was struggling to create this, the compromise that I came upon is that basically you have to define your entire application inside a function, and then that function defines your application. That way, if you're changing variables, they're not smeared over like 3 cells, and you don't know which ones are changed. So it's a little bit, I would say, unusual. But in this case, I've defined this application. It gets a document. It's going to be passed in. And what I do is I create my data. I create a plot. I call a line on that plot. I define a callback inside this function. That's why it's a little weird maybe. But the same thing, slider.onChange. And then I call add root. And basically every Bokeh server application is going to end with, typically if it's not in the notebook, it'll be curdoc.addRoot. In this case, because I've defined my application in this function, it's just doc.addRoot to add the column with the slider and the plot. I'm changing that theme here as well. And that will now show up in the notebook. So this is on GitHub, so I can't actually run it here. But you can find this in the examples repo. You can run it locally, and it'll just plop the example right in the output cell, and then you can scrub the slider, and it'll run that Python code. So, like I said, it's a little bit of a big topic, going over things really fast here. We could have an entire tutorial probably just about Bokeh server if we really wanted to. But I'm pretty excited about the PyScript, PyData stuff. I'm not really working on it myself, but I'm hoping for some really cool things that other people are working on. So, okay, cool. Question?
Just before you leave this subject, can you show a certain example in this where you are overriding one of the tools of the Python call?
Okay, probably. Let's see. Let me try to think about that. Yeah, no, I mean, it's definitely possible. So overriding the tools is a little bit of a nuanced question. Like if you mean I have a selection tool, and anytime a selection is made, I do something with that selection.
So you showed one where you did a selection and you said it was happening in Python.
Yep.
In the histograms.
That is this one.
The data.
Yeah, I think I was fixating on the overriding the tool. In that case, the callback is actually on the selection, on the data source. We'll see that in a second. Let me find that code. That would be, which one is it called? It's selection histogram, appropriately enough. Here we go. So I've created, 3 random normal distributions at X and Y. I'm kind of putting those all together. I'm adding my selection tool. Here's my figure. Here's my, I'm getting those tools. Scatter plot for all of those. Creating a histogram for all the different sides. There's a lot of details in this code that are not really relevant to your question. I displayed the histograms using quads. Quad is another glyph that are for axis-aligned rectangles, and so they match up really well with histogram np.histogram output, so that's why I'm using them here. And so I use quads for that. I create a couple of different figures. Here's what the update looks like, right? So the update is actually added to the data source .selected, and the onChange is for the indices. And the indices are the selection index. So anytime you make a selection on a glyph that uses this data source, the .indices property of that data source is going to be updated with the indices of the selected points. And so that's what the actual onChange is on. It's not, we're not really overriding tools. So it is possible to also override a tool, like there's tools that have callbacks for sure, but this is probably a little more common and sort of indirectly using the tool. And so what happens when we update? Well, we basically compute a new histogram and then we just update our data, right, using the data. So the callback is actually fairly straightforward. I compute new histograms based on the selected data. So I pass in the indices into my arrays to get subselections of the arrays, and then I compute histograms based on that. And then I update my data source, the top values for the vertical histogram or the horizontal histograms and the right values for the vertical histograms. And then that just causes everything to update. So Bokeh in general will try to respond to things automatically. If you set source.data equals to new data, Bokeh will respond automatically. If you update a new column in an existing data source from Python, Bokeh can respond to that. Sometimes you need to be a little more explicit. If you update columns like in place, like you reach into the array and change a value, you might have to tell Bokeh, I changed something, you need to redraw, especially in JavaScript. But anyway, does that answer the question?
Kind of answers the question. And it's a lot clearer from your other widgets how to make a Python callback.
Yep.
Shove something down the data to the browser. But I'm just trying to get a handle more on how to use the tool.
Right. Well,
mess with them more.
here's another example. So I think the reason for that specifically is that a lot of times the tools do something to the plot state. And so in general, the way callbacks work here's some property and I want to respond to that property. And so it's not responding to the tool directly exactly, it's responding to what's changed. So there's also a range selection tool. And if we go to the demo, the gallery for that actually, and we go to interaction, this is a JavaScript callback, but it would be pretty much the same with Python. This tool is a range tool. It can be used to set a range. And so if you wanted to respond to that range, you would put a callback on the range, right? And so that's, I think, the disconnect. And it's not like that there aren't necessarily properties on tools that you could also respond to, but they're sort of more the action that makes something happen, and then you're responding to whatever happens on some other object. And so that's, I think, a lot more.
Isolated into JavaScript.
Yeah. I mean, in this case, though, you could have a Python callback, absolutely. So here I do, sorry. This range tool I'm just sharing, this is interesting. I'm actually just sharing the same range that this updates with the range from the plot. And so it actually just happens automatically. I don't have to do anything at all. But you could say range.onChange start, and then provide a Python callback. And so whenever the tool updates that range, it runs some code, Python code. And so, or you could have a custom JS that does the same.
It's assigned to onChange.
Yeah. So Python callbacks are always going to be either onChange or onEvent for events. So onChange is when like a property changes, like when the title.text changes or when the range.start changes. There are also some events like tap events, like the tap tool events a tap event. And so that's actually probably a more common way to respond to tools. There are pan and drag events and tap events and things like that. And you can have onEvent to respond to those events. And so that's, a more direct connection to tools is probably with those onEvent callbacks. But the corresponding ones are JS onChange and JS onEvent. And that's where you supply custom JS callbacks for the exact same events and exact same properties, right? That's sort of mirrored. Yeah. Question?
On the performance between the Python callback and JavaScript callback, if I were to use them in production?
Not in any generic way. I mean, a lot of times the performance is going to be impacted by how much data you actually need to transfer back and forth. So we did, quite a number of years ago, go through a big process to support a binary serialization protocol for like arrays. So we're actually just sending stuff directly over WebSocket in the Bokeh server case to typed arrays without minimal number of copies, and so that made things a lot more efficient. But if you're sending 100 megabytes of data, that if your callback triggers a send for 100 megabytes of data, we can't make that fast, right? So I can't really comment. It really depends on what you're doing and the specifics of those kind of questions. In terms of execution, I mean, the JavaScript callbacks obviously sort of happen sooner in a sense because it's all in the browser. The property change happens and JavaScript just dispatches to a function. In the Python callback case, something happens, the property changes in the browser. It has to send a message back to the Bokeh server using our protocol. The Bokeh server has to say, okay, I'm going to run this Python code, and maybe you change some property values, and it has to say, I noticed those new data was updated, and send the data back to the browser. So it's definitely a big round trip. But you can see, you can get an idea if you go to the demo site that we were on. This is running on AWS, just a VM, and you can go. Play with these, but none of these have a huge amount of data, but you could imagine some that have more data. This is the IMDb, our Shiny likes to do that. You can see it responds, I would say fairly effectively here. You're released. I guess that would be, most things are released, before then. Anyway, yeah, so you can sort of get an idea. I would say that's acceptably performant. But a lot of times it's going to depend on your data and how big the data is. It's probably the biggest variable there. Cool. Other questions? That's also a really good question. There's a chapter in the user's guide about that. And again, it's one of those areas where it really depends on what you need and what you want. So if you just need to deploy like a Bokeh server application to a few people in your department, you can just run it and just leave it running and tell them how to connect to it, and that's fine. If you need authentication and access, there are some auth hooks you can implement to do that. If you need to scale out to like a huge audience, like an entire company, you may need to run it behind a load balancer. And the old demo site used to use Elastic Beanstalk on AWS to sort of do that automatically. Moved away from that because Elastic Beanstalk's maybe not quite the newest, shiniest thing. But there's also instructions in the docs for running like Nginx and running a load balancer, and you just start 10 instances of the Bokeh server behind Nginx or something.
You're speaking to locations where it would be, but how do you actually deploy it?
I'm not sure I understand the question.
So right now we're opening everything to Notebook.
Yep.
Or you can embed on HTML.
Mm-hmm.
But this is standalone.
Yeah.
It does.
So, yeah, I'm sorry, I don't think I understand the question. In this case, a Bokeh server is an application you run. It's basically a web server that you run, but if you need to scale out to like many thousands of users, you might need to run multiple instances of, like it's horizontally scalable. You could just run 100 instances of the Bokeh server behind a load balancer. How to deploy that really depends on your situation, because you could do it on AWS, Google Cloud Compute. You might have your own infrastructure for it. That's the part where we can't give a lot of specific guidance to, and that actually might be where like Panel could be useful, because I think they try to handle some of those deployment questions a little bit more in an opinionated way. Like this is more like the toolkit level. You can run a Bokeh server, you can run it behind a load balancer if you need to scale out, and we can give a little bit of guidance on that, but it really depends on your situation, exactly what.
In general terms, we're all put into an HTML tag, and then the audience would have to connect to that.
Yes.
IE/port.
So it is possible to, so if you put it behind Nginx, you can, make a CNAME that points to Nginx, and you can put it behind your own domain. There are also APIs for embedding Bokeh server applications in other web pages, right? So if you want to have your own web page that just has a Bokeh server app content in the middle of it, that's possible too. A little bit more complicated deployment scenario, but then your users don't need to navigate it to it. They just go to whatever page you went to, and your app is embedded. But so I'm sorry, your original question was also about deployment. Did that cover everything? Sorry, Timo. I just wanted to make sure I answered the original question as well. Did I? Yeah, I wanted to make sure yeah, I'm sorry, was I able to get, I know you're also asking about deployment. Did that sort of cover some of the bases?
Yeah.
Okay.
And also, sorry, one last question. How is the compatibility of Bokeh and Notebooks? I've noticed that I have to change the code manually.
I have no experience with Databricks, so I can't really comment. I've never used it.
The trick I get around that is basically say everything has HTML
Okay, yeah. Sorry, I've never used Databricks. I can't comment. Trying to think about it. Yeah, the deployment, like I said, that's a big topic. That's a thing we could probably have an entire tutorial about, just ways to deploy. But you might look at panel, yeah, because they try to be more opinionated about deployment and also maybe to streamline that a little bit because they're just at a higher level, and that's yeah, yeah, definitely. Yeah. The discourse.bokeh.org is definitely a great place to come with specific questions. And again, these are the kind of things that really depend on what are you trying to do, specifics. So that's a great resource. If you go to discourse.bokeh.org, we have our discourse, and we try to respond to questions, pretty timely matter, pretty active. So cool. Other questions? Are we at time? We're almost at time. Everybody else? Questions? Going once, going twice? All right, well, thank you, everybody. Cool.